The degrees of knowledge. Chapter 4, Our knowledge of sensible nature. 1. The major types of knowledge. I have said that science, in the precise though very general sense of knowledge in a perfect and irrefragable mode, attains to those intelligible universes immanent in the universe of existence, but these it considers apart, in order to impress them in some way on the universe of existence. These universes of understanding are made up of abstract natures, grasped in themselves or their substitutes, of laws and necessary relations, while the universe of existence is a universe of individuals and events. In this universe there is contingence and hazard, an irreversible flux of singular formations in interaction, none of which ever reappear again in exactly that form. There is liberty. This is the universe in which we live, in the midst of particular and contingent circumstances. It is absurd to imagine that it can ever be wholly under the dominion of science, for all these features which I have enumerated are not, as such, objects for science, in the precise sense of the word. The knowledge of the world of existence, exactly in the degree to which it is concrete and existing, belongs from the point of view of speculation, to experience and to history, to the certitudes and perceptions of memory, the constatation of facts, to conjecture and well-founded opinion. In short, to the work of the intelligence when occupied with the senses. From the practical point of view, it belongs to art, to prudence, to knowledge by connaturality. Science, apprehension in the strict sense of the word, only considers those intelligible necessities which this world invests with its reality. Each of our types of knowledge considers in the world its own universe of intelligible necessities, and that alone. Nevertheless, there is a supreme form of knowledge, a prime knowledge, a knowledge of first principles which can consider all these differing universes together, not in order to substitute a particular form of knowledge which it applies to each in turn, but in order to comprehend its own form of apprehension, to defend and justify its principles, and thus to establish unity. What then, at least in their most general types, are these diverse universes of intelligibility which our intellect sets before itself when it endeavors to disengage itself from the senses? The Aristotelian tradition, which I have already recalled, recognized three principal types, which correspond to what Thomists call the 3 degrees of abstraction, the universe of the principles and laws of mobile and sensible nature, the world of physica, the universe of quantity as such, the world of mathematica, the universe of being as being, and of intelligible objects which as such do not require matter as a condition of their realization, the world of metaphysica. Is it desired to give to these 3 degrees of abstraction names more in conformity with the habits of the modern didactic vocabulary? We can say, making use of the terminology proposed in Chapter 1, that if the assemblage of what the knowing subject can attain, to in the trans-objective subjects, submitted to the grasp of its intelligence, i.e. which proffer themselves to it in order to be turned into its objects, constitutes in a general way the trans-objective intelligible. The first zone with which the human intellect is in relation in this vast totality is the universe of those objects which can only be realized in sensible or empiric existence, what we may call the universe of the sensibly real. How is it possible to surpass this universe? Either in rightly escaping from the real and the renunciation of the endeavor to coordinate knowledge with that supreme value which is existence apart from the mind, i.e., by application to objects which, if they are realizable, can only be realized in sensible existence, but which are conceived of without relation to existence, as it is in the second zone of trans-objective intelligibility, the universe of the preter-real, the universe of the mathematician, or by rising beyond the sensible, in application to objects which are conceived in relation to that supreme value of extramental existence, but which are realized in a non-sensory, non-empiric existence. This is the third zone of trans-objective intelligibility, the universe of the trans-sensible, the universe of the metaphysician, which opens out into the world of the, to us, transintelligible. which can only be known by analogy. These three general types of understanding belong to the order of speculative knowledge. If it is a question of the order of practical knowledge, then, from the heights of metaphysical understanding, the mind returns towards the world of existence as such, and comes, by the stages of moral philosophy and the practical sciences which are its continuation, then of prudence, finally to the point of immediate contact with the singular action requiring regulation. This practical order, however, is not in this present instant our theme. In the speculative order, metaphysics is that supreme and master form of knowledge which was referred to above. It is possible to ask with Kant if metaphysics can be a science, to which I answer, yes, or with Maine de Biran and Bergson if it is in itself an experimental science, to which my answer is, no. In any case, no other form of knowledge, in particular, none of the experimental sciences share with metaphysics the universe of the transsensible, or the third degree of abstraction. Inversely, neither philosophy or any ontological form of knowledge shares with mathematics the universe of the preter-real, or the second degree of abstraction. On the contrary, in the first degree of abstraction we find two differing forms of understanding, one of an ontological order, the philosophy of nature, one of an empyreological order, the experimental science which share out among themselves the sensible and mobile universe. Thus, it is in this degree that we encounter in its most significant form the problem, or perhaps is it necessary to say, the conflict, of science and philosophy. We have already taken cognizance of this problem, as it first of all presents itself to reflection, i.e., from the primarily methodological standpoint of the theoretician of the sciences. Now we shall endeavor to penetrate it from the point of view of critical philosophy. For this it is necessary to return to the consideration of physico-mathematical science, in order to examine afresh this queen and goddess of the experimental sciences, modern physics considered in its general epistemological form. Such a science, we have seen, appears first of all as a mathematization of the sensible, claiming from induction well-founded empiric data, but in order to subject these to a form of deduction and a rule of explication which are of a mathematical order, it belongs to that epistemological type which the ancients called intermediary sciences. Sciences which overlap the borders of physics and mathematics, which are materially physical and formally mathematical, so that they have at once more affinity with mathematics than physics in their laws of explications, and are in the end by which they verify their judgments, more physical than mathematical. One primary point must here again be made clear, which has already furnished a theme in the chapter consecrated to scientific experience. It is not the nature of physical causes considered in itself, which forms the object of physico-mathematical research. Physico-mathematics works in the terms of the physical real, but in order to envisage them from the formal standpoint of mathematics, and of mathematical laws which connect together the measurements collected by our technical instruments from nature. All its concepts are resolved in the measurable, and what verifies the deductive synthesis which it erects is simply the coincidence of its numeric results with the measurements given by experiment. It does not follow that the mathematical beings which intervene in this synthesis represent determinatively real causes and entities which are like the ontological articulations of the world of sensible nature. Physical theory is verified en bloc, by means of the correspondence established between the system of signs which it employs and the measurable data which have been recognized by experiment. But a second point needs also to be signalized, which relates to the observation I have just recalled, the point that physico-mathematical knowledge, while all the time taking its formal texture from the mathematical order, nevertheless remains in the end to which it is directed. More physical than mathematical, and ontological preoccupations enter obliquely into it. Without constituting a science of physical being as such, it obliquely admits ontological values. The system of mathematical relations which it seeks to establish between sensible phenomena, and which constitutes its highest formal object, does not in itself sufficiently satisfy or stimulate the mind of the scientist. His interest is directed towards the physically real, by reason of the reality on which his science is founded and towards which it leads, of the invincibly ontological tendency of the human mind, and the pressure exercised on all sides despite himself. On him by the principle of causality, he is necessarily led to integrate in his mathematical deductions, in the very domain of his own science, into his formally mathematical explanation of observed appearances, a system of principles and causes of an ontologically physical order, which he has built up anew for that end. In the same way we often find, in the initial principle of a new theory, the intuition of some explanatory entity which is physically conceivable. And thus such a science admits of a relation with real being, not only considered as the inexhaustible source of obtainable measurements, but also as the foundation for those reconstructions of which I have just spoken. One thing must be particularly observed: the so constructed entities may be real or rational beings. To him the point is entirely indifferent. It is for the philosopher, if he can, to draw any such distinction between the diverse entities set in action by the physicist. The physicist himself is not troubled by any such question, for all that is important to him is the explicative value of these entities as functions of the system of equation, of physical theory, so that his ontological appetite is as well, if not better, satisfied by rational as by real beings. It is moreover possible that he will be shocked to hear the philosopher speaking in such a way, for a vast misunderstanding rises from the fact that the two attach a different meaning to the word real. The philosopher opposes real being and rational being, in the critical and logical sense which I have here explained, and it is very important to him to discover to which of these two categories the entities with which he is dealing belong. This opposition and this investigation are alike uninteresting to the physicist as such. More, he ignores them, and he assumes, on condition that they are defined by measuring operations which are at least theoretically realizable, that the entities of which he makes use are real, i.e., that they express in an authentically physical way the real bearing of nature. I entirely believe, replies to the philosopher, that they have been made for that. But that is only more manifestly the proof that they are concepts. The physicist immediately adds at that, as though to contradict his colleague, that these real entities are only shadows or illusions, and that it would be ridiculous to ask of them anything concerning the essential nature of matter, real being and rational being in physico-mathematical knowledge. This is a typical instance of the important part, indicated at the end of the preceding chapter, played by rational beings in human knowledge. Because rational being, the order which is maintained by our conceptual objects taken exactly as known, i.e. according to the life which they lead in our mind, because rational being constitutes the specific object of logic, that is the privilege of that science. We are tempted to believe that these concepts only play a part in logic, a grave error indeed. Already, in general comprehension, rational beings are made use of at every instant. It is so, for example, every time we say, evil has triumphed in his soul, or he is a victim of deafness, or the sun rises, for evil and deafness are privations, not essences capable of subsistence, nor does the sun mount in the sky. Mathematics is constantly creating rational beings, such as an irrational number, imaginary number, transfinite number, outline spaces, etc. And it is obvious that a form of knowledge of the physically real which does not scrutinize in themselves, in their own physical or ontological reality, its causes and essences, but which reconstructs this reality purely from the point of view of the relations of measurement which it contains, and according to the exigencies of mathematical deduction in the most generalized form possible, will necessarily make use of a great number of rational beings as its indispensable auxiliaries. Among the entities which enable the physicist to think out his numerical records in use under the present conditions of physical observation, they will be of every kind, from the multitude of more or less elaborated concepts, which only respond to experimental authentications and which translate conceptually the observable causations and structures of the real, to those entities, such as the atom or the electron, which appear in what is concerned with the question in sight as realities. Something exists which the words atom or electron determinatively enclose, and, in what is concerned with the question quid sit, as images which are not only approximations to, but symbolical of primordial parts of the spatio-temporal organization of matter, we may say that they are symbolic reconstruction of real beings. Up to those entities of which Einsteinian time offers today the most famous example, which are in the full sense rational beings, substitutes for realities whose ontological value has no interest for science. Naturally, I am speaking of rational beings founded on the real, for they are founded on the real behavior of nature, on measurements and facts really found in nature, for example, on Michelson's results. There remain also other rational beings, entities incapable of existing as such, and which have no more intrinsic and direct ontological value than the material models constructed in space by Lord Kelvin. How are we to comprehend this formation of explanatory entities, which all present in the most diverse degrees the aspect of concepts, and which nevertheless remain all the time founded on reality? It is by applying ourselves to an exact doctrine of quantity that we can answer this question. Considering things from the standpoint, not of the physicist, but of the philosopher, and to express ourselves in his language, quantity, i.e. the extension of substance, and the metaphysical unity of its parts, which are diverse with regard to position, is a real property of bodies. There are, in nature, dimension, numbers, real measurements, real space, real time, and it is under the conditions and modalities of this real quantity, quantitatively measured and regulated, that the interacting causes in nature develop their qualitative activities, in measure, weight, and number. Physical reality breeds a rich harvest of entitative riches, irreducible to terms of quantity, but by reason of its materiality, and because it emanates from the substance of bodies mediatized by quantity, this world of qualities is intrinsically subject to quantitative determinations. That is why it is accessible by our extrinsic and artificial measurements. Quantity thus ontologically considered, as the first accident of corporeal substances, and as the matrix of cosmic activities, is the object of consideration for the philosopher of nature, who is otherwise incapable of passing on from this to the consideration of those quantitative determinations to which the physical world is subject, and of rediscovering for human use the heights and depths of nature. But quantity can be considered in another way. When disengaged from its subject by formal abstraction, set before the mind in itself, as constituting in itself a separate universe of knowledge, the universe of the preter-real. It is then treated no longer ontologically and from the point of view of being, but quantitatively, or from the standpoint of those relations of order and measurement which sustain the objects of thought so discernible as the forms or essences which are proper to them. Thus, considered it is the object of the mathematician. I am well aware that for many modern theorists of pure mathematics, the latter has no object, but only purely formal logical relations. So that according to the celebrated definition of Bertrand Russell, it can be reduced to a study in which one ignores that of which one is speaking, and does not know if what one says is true, a discipline without content, and in which such objective content as survives is furnished by the physicists. But this nominalist tendency, in my opinion, only prevails in mathematics, because an unjustified abandonment of intuition goes hand in hand with the precious rational acquisitions represented by the development of the axiomatic. This intuition is not intelligible intuition, nor pure intuition in the Kantian sense, as the geometricians for long believed, giving themselves for object a world of Platonic models cut out from the amorphous background which these figures defined, that is, the eternal and conditioning universe, and which was called space. Neither is it an experimental intuition, springing from external perception, the observations and measurements which are effected thanks to the senses and our instruments. It is an imaginative intuition, an intuition of inward meaning, and which only depends on external perception presupposingly, as does imagination itself. The part played by imagination is explained by the fact that quantity, as the first accident of corporeal substance, precedes, in natural priority, the whole qualitative, energetic, and physical order, and thus the whole sensible order, and is so known by the senses by means of sensible qualities, not without, for all that, a whole synergic education of perception. It is, as it were, a common sensible. Imagination in the service of the intellect can therefore penetrate into the world of pure quantity, abstractively detached from sensible matter, and that in the very measure in which imagination, although it presupposes the external senses, is free of them. I mean that its objects are not subject to the relative conditions which affect here and now, those of perception, and which proceed for an actual dependence in regard to external physical circumstances. The intuitive schemas of the imagination, which are in no sense the object itself, but only the symbols or sensible illustrations of the object of mathematics, thus exhibit to us, sensibly, but in a way independent of all experimental conditions, both the essences and the properties which in themselves precede the sensible order and are independent of it. And this action of the imagination, without in the smallest degree diminishing the strict and rigorous rationality implied by logical verifications, as the intuitionists seem too often to believe, is indispensable because the object is not here, as in metaphysics, purely intelligible. The constructive power of imaginative intuition must make manifest, according to the senses, the intrinsic possibility of the entities considered by the mind, above all of those indefinables which are at the beginning of the science, and so assure us that, far from concealing some secret impossibility, these are veritable essences, on whose foundation, moreover, rational beings capable of ideal existence can in their turn be built up. Whatever be these entities constructed or reconstructed by the axiomatic method, which when they are not directly figurable by intuition, at least indirectly or analogically fall into the field of the imaginable, such as non-Euclidean multiplicities, the legitimacy of which became evident in relation to all geometry on the day when, following in the steps of Beltrami, a Euclidean translation of them was seen as possible. They exhibit by this connection with the intuitive sources of mathematics, in themselves a content, a field of truth and rightful intelligibility, entirely in itself independent, if not in the pre-scientific paths which have led the mind thither, of physical formations and experimental existences. In the same way, the confusion of mathematics and logic comes from a fundamental misunderstanding of the nature of logic. A non-reflective science which does not find, as logic does, its object in the objects of the other sciences insofar as they are dealt with by the mind, inasmuch as they are known, has necessarily its own domain of knowable natures, a rightly objective and direct content. This objective content of mathematical observation is then, as the ancients saw, but a whole new synthesis requires building upon the foundation of their principles, being under the terms of quantity as such, of quantity taken in itself, with its own qualities, the relational structures and the properties of order and measure decipherable in limited and unlimited quantity. All the more so that the incessant conquests of modern mathematics oblige us, as by a series of logical exhaustions, to enlarge, revise, and refine many of the notions previously held of these beings, and that, by a form of effort after a total spiritualization of all mathematical knowledge, number for 3 centuries has tended to reduce and absorb the irrevocably potential field of content, and on the other, to escape, if it were possible, from quantity itself and spatiality in order to extend its empire over the whole transcendental multitude. However this may be, these mathematical beings, as I have already pointed out, turn abstract not only existence, but the very order of existence, so that they can be indifferently, and while remaining the legitimate objects of science, real, in the philosopher's sense, or rational. More, it is precisely in entering in the most decided fashion into the region of concepts and pure ideality, that modern mathematics has made so many admirable discoveries. It is thus easy to comprehend how in making a mathematic exegesis of the physically real, which is precisely possible because quantity, which is the first accident of bodies, is grasped by mathematical knowledge at a higher degree of abstraction and immateriality than that of physics. The mathematical physicist can have a mathematician's indifference to the character of real or rational being in the entities of which he makes use, and can even be led, as we can see among our own contemporaries, to employ, in the explication of extra-mental reality, mathematical terms essentially inapplicable to any existence outside the mind. In that very degree, the universe which he constructs will become unfigurable, in the degree to which mathematical rational beings are employed in its construction. And as these are not directly representable by imaginative intuition like the beings of reason or concepts of Euclidean geometry and the arithmetic of whole numbers, the fact remains that mathematical rational beings are founded on mathematical real beings, and that the latter are disengaged from the experience of the real world by mathematical abstraction, as they are grasped in the depths of that real quantity which the philosopher considers ontologically. Quantity is there, it is it which definitely, and that in the most radical fashion, bases on the real the entities built up by the physicist in order to re-find, starting from the constellations of mathematics, the natural earth. From it he draws his measurements effectuated by means of his conventional ruler, and thence he sets off to climb the sky, an unceasing to and fro thanks to which mathematical physics incessantly grows. Finally, although that science is little concerned with ontology as such, it accumulates in its own growth physical facts, which, however wrapped up in theories, however difficult they may be to formulate apart from them, have nevertheless their own and independent value. And among the entities which it has constructed, those carry the strongest indications of reality and are least wrapped up in purely rational conditions, which are most directly related, i.e. have the least theoretic interpositions, to experimental data. Thus, the progress of theoretic physics, that is to say, the more speculative part of mathematical physics, which is accomplished by making more and more use of mathematical ideality, should not make us forget the immense treasure of purely physical results, of facts and observable configurations, in brief, of entia realia, real beings, for all that they are more particularized and less interesting to the philosopher, accumulated by the physics of the laboratory, that is, by the more experimental part of mathematical physics. Ontological and empirico-logical explanation, and the transformations of the notion of causality. In submitting itself fully to the attractions of mathematical explanations, and in translating itself into those terms, in the great revolution accomplished by Da Vinci, Galileo, and Descartes, physics conquered its autonomy with regard to philosophy. More or less completely, more or less rapidly, the other sciences have followed its example. This enfranchisement of the phenomenological sciences has been in progress for 3 centuries and is still going on. If we wish to characterize the method by which this self-determination has been accomplished, it can be said that side by side with the conceptual dictionary of philosophy, which is ontological, a totally different one, which is of an empirico-logical order, has been constituted. Our observation of some material object is the meeting point of 2 forms of knowledge, the sensible and the intellectual. We are in the presence of a kind PF sensory flux stabilized by an idea, in other words, of an ontological or apprehensible nucleus manifested by an assembly of qualities perceived here and now. For example, I find in the course of a botanical excursion a plant unknown to me. It belongs to some species, and by smell and sight and touch I eagerly seek to discover its characteristic features. I can either ask myself concerning it, what is a living plant? Or, how do I classify this in my herbarium? It follows from a case such as this that there are 2 ways in which to resolve our concepts. One which rises towards intelligible being, in which the sensory remains observed by me, but indirectly, and as serving intelligible being, and another, which descends towards the sensible and the observable as such, where doubtless there is no absolute abandonment of the idea of being, without which indeed there would be no thought, but where it is subservient to the sensible in itself, and before all to the measurable, and only remains in the mind as an unknown assurance of the constancy of certain sensible determinations and measures, and as allowing for the drawing of stable limits round the object perceived by the senses. This is certainly the way in which concepts are resolved in experimental sciences. I call these two methods respectively the ontological, in the widest use of the word, and the empirico-logical or spatiotemporal. It goes without saying that an ontological explanation being continues to be considered, at least in so far as we remain, as in this chapter, within the limits of the first degree of abstraction, in the terms of observable data. But the mind in its consideration of these seeks for their inward nature and intelligible reasons, which is why it comes in following this path to the statement of notions like those of corporeal substance, quality, operative potency, material or formal cause, etc., all of which, though applying to the world of the observable, do not describe objects which are in themselves representable by the senses or expressible in an image or spatio-temporal scheme. They are not defined by observations or measurements which can be performed in a particular determined way. In empirico-logical explanation, on the other hand, ontology is still there, as I pointed out a moment ago, since it is a question of intellectual knowledge, and we do not cease to be reasoning animals by taking to experimental science. In that sense, the scientist, like every other man, remains invincibly ontological, but in this case, the ontology is oblique and indirect. The ontological is never under these terms sought for itself. It is only there as a basis for empiric definitions and representation or of physico-mathematical entities. The mind considers the object as at the origin of the registration of certain constants, as a complex describable by its encounter with our senses and our instruments in a certain particular fashion, so that the essential conditions of the observability of the object play a determining part in regard to scientific explanation. All the derivative notions introduced by science in order to assist description, so that the trees should not conceal the forest, result in its condensation into the measurable and the observable. And if the analysis is conducted in terms which are not in themselves attained by the senses, or, if it is a question of psychology by introspection, for all experimental psychology is not necessarily behaviorist, these always remain conceived in relation to recordings and imaginary perceptions. For example, factual impossibles, as in the case of the ether, and like hidden observables indirectly attained thanks to the patent observables which require them, so that all the motions employed are strictly held within the order of what has been, could have been, or is experienced by the senses. In this sense, and by an abridgment of language, one can say that empiriological explanation has no ontological, i.e., directly ontological value. It only attains the being of things obliquely and as an indirect foundation, without making it known in itself. It works in the natures or essences of the corporeal world, but these are not as such its object. But in this very category of the empiriological two, clearly different types of explanation can be distinguished, according as the empiric content, i.e., the measurable, receives its form and its laws of explanation from mathematics. Then there is the type of empirico-mathematical explication characteristic of mathematico-physical science, or as the empiric content, in this case, the observable in general, implies a form and rule of explanation which is purely experimental. Then there is the type of empirico-schematic explication characteristic of the sciences of observation not subjected to, or at least not yet subject to, mathematical terminology. I shall return to this distinction later. At this point, I only wish to point out that in the one case as in the other, the comperiological dictionary proper to the phenomenological sciences tends to set itself up in a more and more perfect independence with regard to the ontological terminology of philosophy. This kind of purification is particularly far advanced in physics, but maybe by the elaboration of new concepts or the rephrasing of definitions, maybe by a new use, applied in total to sensible verifications, of general concepts, of philosophic or pre-philosophic origin. Sciences such as biology or experimental psychology, which can be included, it will be seen in a moment under what conditions and with what reservations, in the empirico-schematic type, tend, yes, they also, to create for themselves a notional vocabulary which is more and more self-determined. Since they abide in a much less precarious continuity with philosophy, it is more difficult for them than for physics to isolate this notional dictionary, to prevent the entry of philosophical concepts which, in this region, give space for pseudo-explanations. Nevertheless, they persevere in the endeavor, and we can observe even a preference for the most rudimentary conceptual equipment, like the system of psychological notions employed by the Freudian school, on the one condition that it will assure this independence. Thus, in a general way, in all empiriological recording, the resolution of concepts is made in an infra-philosophic direction. It is not what things are in themselves, which is the point of interest. What is important are the possibilities of empiric proof and of mensuration which they represent, and also of connecting together, according to certain stable laws, the data furnished by these means. Every definition must be made, no longer by the nearest gender and specific difference, but by observable and highly determined measurable properties, to each of which is assigned in each case the method of recording and of practical verification. The possibility of observation and measurement thus replaces for such forms of knowledge the essence or quiddity sought for in things by philosophy. The registration of conditionality, which keeps the mind attached to the sensible and the imaginable, tends in the same way to substitute that of causality, which, when it is pure, causes the mind to progress at once to reasons of being not representable by the senses. Such, at least, is the ideal to which empiriological knowledge leads. In fact, its noematic material is far from being homogeneous, and if one makes a cross-section of the procedure a whole, scries of conceptual strata are visible in the course of one notional function, of very different intelligible density and forms of refraction. Not only, for example, is the existence of natures or stable essences in the corporeal world a postulate of the pre-philosophy of the scientist, but, in the very operations of science, the natural notion supplied by common sense of these ontological nuclei continues to operate on certain planes, while in others it has been replaced by a scientific notion remodeled according to the possibilities of measurement. In the same way, a scientist will make use at once, on differing planes of conceptualization, of an ontological notion furnished in a confused state by common sense, and incarnated for him in a measurable or observable relation, of the cause as an activity productive of being, and of a popular empirico-ontological notion, which is in truth intrinsically ambiguous, of the cause as a phenomenon producing another, and of a scientific, philosophical, or mechanical, empirico-schematic one of the cause, as a phenomenon to which another is connected by a universal necessary concatenation which expresses a world law, and finally, of a purely empiriological notion of the cause, from which all philosophical content has been withdrawn, as the spatio-temporal condition of a phenomenon, or the constellation of observable and measurable determinations with which a phenomenon is bound up, a notion which finds its perfect expression in the formulation of physical connections by means of mathematical relations, such as those which furnish the differential or tensorial calculus. On this plane of conditionality, the idea of transitive action, in incessant transmutation among the various masks of causality, of which here I have only given a brief abridgment, is completely shredded away into that of phenomenal co-determination. At the same time, science has in this relation, as we see today, reached something of a critical point. In the course of its own line of progress, it has seen some of its laws take on the form of statistical laws, which thrust causal determinations into the background. Others transformed into what are called identical laws, or truisms, which explain the behavior of things by that behavior itself, where it has become, thanks to some mathematical transmogrifications, a property of the structure of a world, built up for that end by the mind, which in particular is what has befallen in the geometrical reshaping of certain sections of physics, such as gravitation. But above all, in crossing the threshold of the atomic world, science has discovered that mechanics cannot account for the movements of a particle in a way which is on all occasions entirely defined. We learn by wave mechanics that it is impossible to assign a fixed trajectory to a particle associated in a group of waves. This only allows the knowledge of the probability of the presence of that particle in a more or less extended area. And the particle can never have at once a perfectly defined position and perfectly defined energy. The quantum mechanics of Heisenberg and Bohm, which are in agreement with the wave mechanics of Louis de Broglie and Schrödinger. But in exhibiting that, it is necessary to give to their principles a statistical significance, and seeing only in the wave a pure mathematical symbol, abandon even the possibility of following the movement of each particle. Science has thus come to the principle of indetermination, or the relations of incertitude of Heisenberg. It is only possible to determine the speed of a particle by leaving at that moment its position undetermined, or to determine its position by leaving its speed in indetermination. In order to precisely observe the position of an electron, it is necessary to disturb its speed, in lighting it up with a short-length wave whose quantum is of high energy. And in order to measure its speed exactly, it is necessary, in only lighting it with a long wavelength of a low quantum, to render its position uncertain. Finally, it is necessary to sacrifice the traditional idea which attributed to corpuscles a well-defined position, speed, and trajectory. More, we can no longer attribute a well-defined energy to the corpuscle, but only speak of the probability by which it manifests itself with such energy. The series of waves is only, in Heisenberg's phrase, a bundle of probabilities. So we see science so far obliged to renounce determinism, precisely in the form in which determinism is scientific, and as it means, not that the course of events excludes any contingents, but simply that the laws of nature can, in the given circumstances at a given moment, strictly determine the way in which in the following moment such material phenomena will offer themselves to observation and measurement. The principle of causality, in the very form of that phenomenal codetermination to which it has been reduced by science, is seen as open to exceptions, riddled with lacunae, robbed of its universal value. A result against which certainly those who abandoned a truly, philosophically ontological standpoint have no right to protest. With science devoted to pure empiriology and empiriometrics, more and more under the spell of mathematical rational being, we owe thanks to the new physics for the degree to which this has been made evident. It was obvious there could be no other end. But the scientists do not seem prepared to take it so lightly, for it has been the general belief in the principle of causality, which was the vital impulse behind Recircli. Like Einstein, they hope that strict causality will one day recover its sovereignty in physics. Einstein gave voice to this hope in 1927. Since then, microphysics appears rather to have accentuated its indeterminist tendency. Whatever form it may assume in the future, and even if a return should become possible to the methods or only the idea of strict determination, what is important to the philosopher and singularly lights up the nature of empiriological apprehension, and what justifies this digression, is the fact that science has one day come to know a state of mind with regard to causality as characteristic as the one which we are actually observing. The heterogeneity, to return to our theme, of the materials in one notional line brought into action by science is thus sharply apparent. A great field of critical analysis is so opened up, which I have only wished to indicate in passing. The essential point is to comprehend the grave error into which we fall when we consider science statically as complete, as all of a piece, not only with regard to its extension and its objects of knowledge, where the error is only too clear, but also from the point of view of its internal noetic morphology, its intention, and its typical forms. At the very point where it detaches itself from the pre-scientific basis of common sense, in order to build itself up more and more purely as a science. its extensive growth is accompanied by a progressive internal formative movement, which brings it into connection with certain determined epistemological types, which it has only as yet partially realized in very varying degrees. But if a total and homogeneous realization of these ideal types must be regarded as an asymptotic limit, what is very remarkable is that, anticipating, so to speak, future possibilities and before all subject to the exigencies of its ideal form, science only makes a material use, and as if without recognizing or qualifying for them, of notions which belong to the less developed strata of conceptualization. The formulas of scientific intelligibility, above all, pass by the higher stages, the notions which are most typically pure. Thus, in the forms of knowledge with which we shall be occupied presently, in the phenomenological sciences, the formally activating value is attached to the elimination of the ontological and the philosophical for the benefit of a wholly empiriometric or empirico-schematic explanation. It is comprehensible that, for a mind limited by its habitual preoccupations to intelligibility at this degree, philosophic notions may lose all significance. In a certain sense, the experimental sciences have progressed by fighting against the intelligence. For the intellect has a natural tendency to introduce into the conceptual register proper to these sciences significances which belong to another, the philosophical, and which in consequence disturb and retard experimental knowledge as such, by preventing its approximation to its pure type. Finally, it is possible to say that the natural sciences are bound up with ontology in a way which is implicit, obscure, thankless, and unavowed, and this for two reasons. First of all, insofar as these sciences necessarily presuppose a philosophy or pre-philosophy, a latent substructure, which may be rudimentary, unformulated, or unconscious, but which is nonetheless real, and which assumes as indubitable postulates the existence of things as distinct from thought and the possibility of attaining them more or less completely by knowledge. Then, insofar as science itself exists in oblique reference to things as the foundation of the explanatory representations which it elaborates, and by the simple fact that for it all rests on observation and then on the intuition of the senses, whose witness the scientific employment of measuring apparatus and defining instruments dissolves, so to speak, into a multiplicity of points of perception, of graduated readings, but which remains nevertheless always presupposed by these works. Does it not implicitly declare, like the intuition of the senses themselves, the existence in the exterior world of hidden ontological structures, which, no more than the senses, can it scrutinize in their own individual being? But except for this double relation, which is at once implicit and explicit, to the ontological, the natural sciences tend to separate in their own particular structure, to the farthest degree the observable from the ontological, the new physics. I have spoken of physico-mathematical knowledge in general. A marvelous renaissance has today taken place in this form of knowledge whose importance cannot be exaggerated. With extraordinary rapidity, its fundamental concepts have been revised and readjusted. The foundations of Newtonianism have been shaken, and the theoreticians of science attribute, it seems with good reason, to the work of Einstein and Planck a magnitude equal to that of the great initiators of the classical age. Few spectacles could be more beautiful or more moving to the mind than this of physics advancing on the path of its destiny like a great galleon in full sail. Here, for a moment or two, the course of these reflections must pause, not to indulge in any rash forecastings of the future of the theories of the new physics, but to inquire whether its scientific bearing confirms or invalidates the epistemological principles which up to now I have been endeavoring to establish. From the epistemological standpoint, it exhibits first of all an effort to free our knowledge of nature from the dominion of a number of preconceived mathematical ideas, and, to speak briefly, a reaction of the physicist as such, the theoretical physicist, against the prearranged framework imposed on physics by rationalist mechanics, in itself held to be a purely mathematical science. Mechanics, for all that, might itself become a department of physics at which any Aristotelian would rejoice. For it is good peripatetic doctrine that motion is in itself a physical, not a mathematical thing, and what the mathematician retains, the variation of the distances of a point from coordinated axes, which is evidently, as Descartes said, reciprocal, and which posits no more reality in the point than in the axis, and vice versa, is not movement itself, but its effect or its translation into the register of ideal quantity. In itself, mathematics makes movement into an abstraction. This is why the mechanistic theory, which has been taken as the metaphysical universalization of mechanics in the classical sense, while claiming to explain all nature in terms of extension and motion, is in reality a jettisoning of the reality of motion, which has become wholly ideal. The new physics has renounced the attribution to any of the elements in the scientific picture of nature of an absolute character, i.e., the possession of certain unvarying quantitative determinations or properties, which appertain to elements of the same kind, when they are considered in themselves or their essences by the mathematician, in independence of all physical means of observation and measurement, and which was attributed to them by classical physics because it set up its picture of nature in a framework, not only as was normal, mathematical in type, but which has been thought out and established in a mode of conception and determination proper to the mathematician as such, not the physicist. It has renounced the absolute dimensions of bodies, an absolute setting out in space as in time, the absolute character of mass, any system of privileged axes, whether it is a question, as in limited relativity of the Galilean systems of reference, uniform in movement with regard to others, or, as in generalized relativity, of systems of reference having no matter what movement with regard to others. Again, it is permissible to regard the quantic theories and the growing importance given to the discontinuous in these new scientific conceptions as a revolt by physics against the privileged position accorded by mathematical analysis and the recourse to differential equations in the exposition of the laws of nature to conditions of continuity. The reassertions of a form of realism in the physicist is such, that is, of the resolution of the primordial concepts of science in complexes of elements exclusively determined by really or imaginably executable physical measurements, has thus risen up to break an image of the physical world which the classic age had drawn out in accord with the ideal supraphysical privileges of the mathematical universe. The physicist has recovered in the same stroke all the native force of the urge and desire immanent in his habitual occupation, which seek to disclose the secrets and ways of nature, the rightful mystery of the world of bodies, rerum cognoscere causas. Things have not changed from this point of view since Lucretius and Virgil, and it is with good reason that the decisive progress which has renewed our science of matter is attributed to the intuitive faculty for the physically real, amid the most abstract symbols of mathematics. What indeed would be the primum movens of any physicist, even if he be the most devoted adherent of positivistic macerations, without such a desire to penetrate to what is? They thus claim to possess mathematics without being possessed, to treat it as a simple language, a mere instrument wherewith to scrutinize nature and matter. But how do they set to work on this plan? And what are the results, in fact? We see the new physics expressly leading to a complete geometrization. It is in taking the fullest cognizance of this demand, which is inherent in the very nature of modern physics, that it has built itself up and achieved all its victories. But it can only advance along this road by an even more complete renunciation than that of classical physics of all ontological claims, and by multiplying more than ever, and with all the advantages of full advertence, physico-mathematical rational beings. It has been frequently pointed out, and it is not out of order to fix in passing the meaning of this comment, that Einstein's theory of relativity proceeds in fact from an absolute need and an effort of the widest span to raise science to a high degree of independence with regard to the particular standpoints of the various observers. In this, the very spirit and ideal of physical theory has evolved and progressed. In the new synthesis, the laws of nature are set out in the same fashion, and magnitude, par excellence, which is like the sovereign of the physical world, the velocity of light, velocity for which length becomes zero and the material mass infinite, is measured by the same number, for the observers of no matter what system of reference, whatever may be the motion of the systems in question in relation to one another. The image of things in themselves and the connections between happenings varying in consequence. I have already had occasion to mark the importance of the necessary distinction which should be drawn between the laws of nature and the concrete course of events. We can say that if the new physics stamps with relativity, the course of events, not with regard to the events themselves produced here and now, but in the setting out of their relations in space and time, it is in order to assure at their expense universally absolute form for the laws. But it is outside things, if I may put it so, and in the formal texture of its deductive system, that physico-mathematical science attains to this most absolutely, to that expansion in the unconditioned to which all spiritual things tend, not in the discovery of the absolute in things themselves, rather, on the contrary, by escaping from the ontological, by renouncing the integration and the scientific picture of nature of the absolute elements recognized in the real by both philosophy and common sense, and in the replacement of these elements by rational beings elaborated in accord with the exigencies of the deductive system under construction. The philosopher knows that bodies have absolute dimensions, that there are in the world absolute motions, and absolute time, simultaneities which are absolute for events divided as far as may be in space. Absolute signifies here entirely determined in itself, independently of any observer. The knowledge of what these are, the discernments of these absolute dimensions, movements, simultaneities, at a distance. Time, by the aid of our means of observation and measurement, the philosopher renounces, voluntarily conceding that it is not possible. It is sufficient for him that they can be discerned by pure minds, which know without observing from a given point of space and time. The physicist makes a like renunciation, and with good reason, but for him, he is not a philosopher, and is only occupied with what he can measure, and insofar as it can be measured, the existence of these absolutes does not count, and in their place he knows only, and manipulates relative entities reconstituted by means of measurable determinations, beings of reason with a foundation in reality. Could the distinctive features of the realism of the new physics have led in themselves to any other result? To make the whole object of exact science consist in pointer readings and similar indications, and to turn out of physics every notion which is not resolvable into physically effectable measurements, is to free physics from that ideal armature which had descended into its stuff from the heaven of pure mathematics, but it is at the same time to free it, much more radically than ever before, from all ontological notions and every mode of ontological conceptualization, whether it is a question of the naive ontology of daily observation or of that of philosophy. The process to which the vocabulary of physics has been subjected by the theory of relativity is very significant from this point of view. When we listen to a discourse by Einstein on simultaneity, it is striking to hear him constantly returning to the question, what does the word simultaneous signify for me as a physicist? And he always responds, in accord with that methodological theme whose fundamental importance I have stressed. Give me a definition which will tell me by what collection of concretely realizable measures I can in each case verify what two events do or do not deserve to be called simultaneous. Then alone, I shall have a definition of simultaneity usable by a physicist and valuable in his eyes. There can, therefore, be no question here of the essence of simultaneity, what it is in itself. Time, simultaneity, space, are concepts entirely remodeled and stripped of any philosophical color. They take on for the physicist a purely empiriometric significance, to which it would imply a great deal of simple-headedness to apply any directly ontological value, and physics has thus achieved the completest possible enfranchisement from philosophy. In the same stroke, it tends to achieve an equal deliverance from common sense, not only from that common imagery which was in question at the beginning of the previous chapter, but from the philosophy implicit in common observation, the natural principles and data of the intelligence, except in what is concerned with the principles of mathematical interpretation and the ontological postulates implied by its laws of observation, a legitimate deliverance from the moment it is accompanied by an equally wide renunciation of ontology. It follows from these considerations that the idea of discovering the nature of matter and of corporeal things in itself must appear to the new physics, even more decidedly and to a higher degree than to all the physics of yesterday and before, a pure archaism. The scientist of today cannot indicate the essence of the real. It is this that primarily distinguishes his attitude from that of his materialist predecessor, and even more, from that of the medieval physicist. He does not even claim to attain to the being of the real, which, on the contrary, he sees as enveloped in profound mystery. It is remarkable that the quantum theories, in the very act of stressing the unfigurable character of the universe of science, render still more profound the rupture between that universe and knowledge of an ontological type. Today, the scientist reflecting on his work is only aware of a world of symbols. We have suffered and we still suffer from expectations that electrons and quanta must be in some fundamental respects like materials or forces familiar in the workshop, that all we have to do is to imagine the usual kind of thing on an infinitely smaller scale. It must be our aim to avoid such prejudgments which are surely illogical. And since we must cease to employ familiar concepts, symbols have become the only possible alternative. If then only pointer readings or their equivalents are put into the machine of scientific calculation, how can we grind out anything but pointer readings? Whenever we state the properties of a body in terms of physical quantities, we are imparting knowledge as to the response of various metrical indicators to its presence and nothing more. After all, knowledge of this kind is fairly comprehensive. A knowledge of the response of all kinds of objects, weighing machines and other indicators, would determine completely its relation to its environment, leaving only its unbeatable nature undetermined. The Victorian physicist felt that he knew just what he was talking about when he used such terms as matter and atoms. Atoms were tiny billiard balls, a crisp statement that was supposed to tell you all about their nature. But now we realize that science has nothing to say as to the intrinsic nature of the atom. It is, like everything else in physics, a schedule of pointer readings. Scientific investigation does not lead to knowledge of the intrinsic nature of things. The external world of physics has thus become a world of shadows. Professor Eddington in this seems to forget that not only do the measurements collected by our instruments from nature give us something real, which may resemble a shadow with regard to our familiar universe. Nevertheless, the philosopher knows that there are very many differing forms in which an aspect of things existing in themselves may appear to us, but also that the first degree or stage of conceptualization, often very elaborated, when we disengage from these measurements a description of the observable behavior of things, also sets us in the presence of realities, I say observable and measurable, and taken precisely in that sense, introduces us into a world of facts, of observable causations, of observable structures which the theoretical physicist tends to hold simply as matter offered to his constructive genius, but which the physicist of the laboratory is not disposed to allow to be misunderstood as already making an authentic part of physical science itself. These facts can be established more or less certainly, more or less hypothetically. They can imply in one degree or another an ideal achievement of the real by the reason. They nonetheless result from the order of real being. Notions such as that of the constitution of gas by individual molecules in endless agitation, or of the reticular structure of crystals and a crowd of other similar ones, must be held for something other than symbols, exactly insofar as they are translations of the measurable and the observable, and before theoretic effort, in the endeavor to penetrate their significance and discover, in a complete expiation what they tell us, gives us to understand that in the last analysis, we can only know symbolically what they say. But it is precisely this second degree and second stage of scientific conceptualization that Professor Eddington has in mind. And there it would indeed be foolhardy to reject his evidence. The two characteristics which we have discovered in the new physics seem at the first glance contradictory. On the one hand, a mental urge towards the physical in itself and the mysteries of its behavior, a will to physical realism. On the other, the construction of a world of symbols and a more decided recourse than ever before to geometrical and mathematical rational being. This contradiction is purely apparent. The paradox is explained by what has been said above concerning physico-mathematical science in general and gives us the best possible illustration of the theory of scientia media. In its opposition to Newtonianism, the new physics recalls to our minds the fact that physico-mathematical knowledge is primarily physical, and at the same time, the degree to which it reaches beyond Newton manifests even more strikingly its formally mathematical character. The physicist regards mathematics as simply supplying an instrument and a language, but neither a simple language nor a simple instrument. This language supplies the laws of analysis, conceptualization, and explication, which give his science its proper scientific form. I said that he wished to know the nature of things and their physical causes. Did I say that he wished to know either that nature or these causes in themselves? Rather, I said that he renounced the knowledge in themselves of the nature of things and their physical causes. Reduced to their essential meaning, the formulas which I have quoted from Professor Eddington can signify nothing else. But did I say that he renounced the knowledge of them absolutely and in every way? The urge which drives him towards the physically real can only attain to the real in its measurable aspects, in its measurable structure as such, by turning it into mathematical terms, and finally by constructing something else in its place. The physicist wishes to penetrate the secrets of matter, but the very type of the science with which he is connected interdicts his attainment of the nature of matter in itself. He attains to it ill its observable and measurable determinations, which are real by that very fact, which are for him the substanza of its essence. And he scrutinizes and penetrates it thereby in the very degree to which he transmutes it into mathematical symbols. Let us say that his form of knowledge is not knowledge of the real, the given real, by the real, a more profound reality, but of the real by the mathematical preter real. It is a knowledge of the physically real, which becomes symbolic inasmuch as its mathematical regulation obliges it to attempt a complete explication, where will be formulated in wholly quantitative terms that of which the forms and the formation come from a world of qualities. Or rather, if it is permissible to use here an old Platonic word, which is perhaps more expressive than the modern symbol, it is, at least with regard to that second stage of conceptualization of which I spoke a moment ago, a knowledge of the physically real by means of myths, that is, verified myths, i.e., which accord with the measurable appearances and which save them, a science at once experimental and mythopoetic of the physically real. This is what gives to theoretical physics in its most inspired discoveries such a striking resemblance to artistic creation. But, and this is the marvel, this is a question of a speculative art, of an art for the purpose of knowledge, where the imagination is only fruitful in submitting to the constraints of a world of rigorous determinations, of laws established with the strictest exactitude. I have already pointed out in a previous chapter that Plato saw very clearly the rightful method of mathematical knowledge. He also saw, and with an equal penetration, that the creation of scientific myths, the noblest form of rational beings founded in reality, is a necessary consequence of that method. The myths of the Timaeus may have grown old, but it is in no avowal of impotence or any flight into poetry that Timaeus makes use of myths. It is by virtue of an admirable intuition of the proper conditions of physico-mathematical knowledge and of what we call the exact sciences, when, ceasing to be purely mathematical, they seek to explain the world of experience. Aristotle was occupied with something else which Plato did not see. He was founding the philosophy of sensible nature, and for that he had to oppose Platonic metaphysics and the theory of ideas. But though Lie certainly recognized the existence of scientia media, middle knowledge, and though he himself constructed, in the theory of the homocentric spheres, a physico-mathematical myth of the first magnitude, he accorded, it seems, a full ontological value to these spheres, a reality not only fundamental, with regard to their foundation on the nature of things, but formal and entire, in their formality, their thinkable construction itself. Because of the prevalence in him of the standpoint of the natural philosopher, he did not see as clearly as Plato did the necessary part played by ideality in the mathematical knowledge of natural phenomena in the very degree to which it is an exact science. Suppose that a scientist, shut up in a ground-glass bell, in which he received by radio the scientific information on which he worked, learnt one day of the existence of a certain machine capable of projecting its own weight to a height 300 times greater than its own. He would have difficulty in even approximating to the idea of this machine, unknown in itself, as a sort of catapult constructed in accord with given data, whose image he would make more precise and correct in the degree to which he was supplied with new information. If he learnt that this machine presented the features of what men call memory, i.e., modified in the degree to which it functioned its way of functioning and of responding to stimuli, which was not the case with the instrument he had himself reconstructed, he would perhaps resolve the difficulty by endowing the space occupied by it with some new dimension, according to which the past of this machine was conserved and modified in some invisible way its structure. We others, who walk about in streets and lodge in inns, are able to know that this machine in question is called a flea. The scientist could not know this, but the construction which he incessantly remodeled, from top to bottom in the stress of hours of crisis, would present at each instant the sum of all the measurable properties enclosed in the flea and actually known by it. And it is clear that in creating such an imaginary yet real model, exact and rigorous in all its determinations, he could continually learn, but by means of myths and symbols, more and deeper perceptions of the nature of the flea. It would be inexact to say that he did not know this nature, only he does not know it ontologically or in itself. Let the simplicity of this metaphor be excused. It only translates into terms of the senses the way in which symbolism and realism are indissolubly united in the more highly conceptual part of theoretic physics. It would be erroneous to sever and oppose them. In this particular region, they compose the warp and the woof of one stuff. It is by the creation of its most daring myths that physical theory most profoundly scrutinizes, in its own way, which is not that of philosophy, material reality. It is by connaturalizing the intellect with material reality, not grasped in itself, that it constructs on the latter and in its place a universe of symbols or verified myths. The closer it presses to physical reality, the more it constructs these rational beings far removed from our common experience, as in the finite world of Einstein, where exactly by going away from a point it is finally rejoined. The further it transports us from the nature of the atom, or the electron considered in itself, the nearer it comes to this nature. Let me hasten to add that physical theory is not symbolic as such. It is, as I pointed out above, indifferent in its use of real entities held in the measurable behavior of things, or of symbols and rational beings, founded on this same measurable behavior. And in fact, we realize that today it is becoming more symbolic in the degree to which its conceptualization rises higher, and the explanation which it elaborates becomes at once more universal and more pure, with regard to its epistemological type. The epistemological complexity of the scientia media, middle knowledge, may disturb the taste for simplification and easy classification to which philosophers sometimes cede, but indeed, they must take it as it is. Indeed, the interpretation proposed here of physical theory is more realist than that of some philosophical physicists, notably Professor Eddington's, not only because I have insisted particularly on the epistemological importance of those real entities, either simple observable data, or conceptualizations more or less approximate to these, which also make part of physics, and which the new theory brings into operation, but also because, while recognizing all the inevitable ideality imported by the geometrization of physics, it also affirms even there its value as a knowledge of the real. Knowing as I do as a philosopher that the existence of corporeal substances and their nature is not attained in itself, but that nevertheless it attains to them in the substitutes which it has elaborated to that end, and which are founded on these natures, and which serve best when least claim is made for a progress through them to the ontological articulations of reality. Indeed, if Professor Eddington seems to lean towards a form of idealism or a pure symbolism in his reflections on physics, since he seems to hold sensory perception already itself symbolic, which implies a complete metaphysic, he is assuredly much more of a realist when he speaks as a working physicist. Has he not said himself, "The physicist, so long as he thinks as a physicist, has a definite belief in a real world outside him. For instance, he believes that atoms and molecules really exist. They are not mere inventions that enable him to grasp certain laws of chemical combination. In truth, there is no mental attitude more contrary to idealism than that of the scientist who, face to face with nature, at once urgently seeks the inexhaustible ontological riches with which it is charged, and abandons the idea of penetrating to them by any other means than those which he knows are necessarily inadequate. He has the sense of finding himself confronted by an enigma at once wonderful and perturbing. He contemplates it with an almost fearful respect, which is perhaps not without a certain resemblance to the feelings of a believer before the mysteries of his faith. A digression on the question of real space. There is no clearer word than the word reality, which means that which is. But its use implies the drawing of many distinctions and a critical consideration which is frequently difficult. Let me try, in order to apply in a particular instance these considerations of the new physics, to examine the question of real space. What is meant when it is asked whether real space is Euclidean or non-Euclidean, or whether the space postulated by Einstein's theory of gravitation is or is not real, or when it is said that, thanks to the new physics, one of whose particular characteristics is to carry to a higher degree than any attained heretofore the identification of geometry and physics, that nevertheless, we are approaching drawing the distinction between geometric and physical space? This distinction, I hold, is fundamental, but it is highly necessary to understand its veracious meaning. The word real has not the same meaning for the philosopher, the mathematician, and the physicist. If we do not keep this diversity in mind, the question I have asked turns up nothing but a tangle of ambiguities. For geometry, a space is real, which is capable of mathematical existence, i.e., which do not imply internal contradictions, and which rightly corresponds to the mathematical notion of space, i.e., which rightly constitutes a system of objects of thought, verifying geometrical axioms. And it is obvious that from this point of view, in virtue of what might be called the circumcision of various geometrical systems, these being mutually translatable and inclusive, so that non-Euclidean geometries contain the Euclidean as a particular instance, and nevertheless can themselves be constructed by means of Euclidean materials. All these geometries and all the still more general geometries which could be invented are equally true, and their spaces are therefore equally real. Euclidean space holds no particularly privileged position in any way, except that the constructibility of Euclidean entities by imaginative intuition is the fundamental guarantee for the notional coherence, absence of internal contradiction, of both Euclidean and non-Euclidean geometric entities, since the latter can always be translated into a Euclidean multiplicity. In other words, of the compatibility of both Euclidean and non-Euclidean axioms. For the physicist, a space is real when the geometry to which it corresponds permits of the construction of a physico-mathematical universe which coherently and completely symbolizes physical phenomena, and where all our graduated readings find themselves explained. And it is obvious that from this point of view, no space of any kind holds any sort of privileged position. For a long period, Euclidean space sufficed for the interpreters of physics. In order to construct a satisfying image of observable phenomena, they postulated, as common observation suggested, Euclidean geometric properties and attributed to factors of another, physical, order, all properties not so foreseen. Today, physics has abandoned this division, and for the interpretations of a synthesis, where geometry and physics may be as far as possible amalgamated in proportion to the degree to which they sever in nature, it has recourse to spherical or elliptic spaces. It is these that physics holds real, in the sense I have just explained, and tomorrow there may well be others. But it is neither from the standpoint of the physicist nor of the mathematician that I see the problem. For me, the question is to know what real space in the philosophical meaning of the word is, i.e., as a real entity in opposition to a rational one, and as designating an object of thought capable of an extra-mental existence, not certainly in the way it exists in thought, but rather as an assembly of features objective in themselves which integrate its notion or definition. Taking into account the peculiar conditions of mathematical beings and the rational condition, ideal purification, which always affects their very definition, we can say that a mathematical entity is real, in the philosophical sense of the word, when it can exist outside the mind, not doubtless under the conditions proper to mathematical abstraction. Nature knows no point without extension or line without density, nor abstract number. The point, the line, the whole number are, for all that, real beings. But insofar as its definition makes visible in a pure state or in its ideal perfection some characteristic, resulting from accidental quantity, which exists or can exist in the world of bodies. In order to be thus an ens real, such an entity does not cease to be mathematical, although it can only enter into actual and sensible existence by losing its mathematical purity. Taken as existing in the thing, it is a feature of the latter which can only be scientifically known when detached by mathematical abstraction, which leaves on one side all properties relevant to the activity of bodies, their movement, qualitative diversity, sensible characteristics, to keep only what subsists after the emptying out of the physical. Let it be added that the various geometrical entities, Euclidean, Riemannian, etc., although they may be mutually translatable, so that all these systems are equally true, nevertheless cannot be all equally real in the philosophical sense of the word. The right hand of the elliptic plane, for instance, and the figure which corresponds to it in the Euclidean instance, are not different expressions of one thing. In the order of the mathematical preter-real there is no other thing than the object of thought itself constructed according to such and such a system of axioms. They are intrinsically different entities, belonging to intrinsically different worlds, which analogically correspond to one another. To affirm the reality of one kind of space is thus, at the same time, to affirm, not the reality, but the unreality of all the others, of which no entity can be thought of in the latter. How then are we to know if a mathematical being, and in particular this system of geometric entities which is called a space, is or is not real in the philosophical sense? Mathematic intelligibility in itself can tell us nothing, for it is as much concerned with rational as with real beings. Neither can the verifications of our senses or our measuring instruments tell us more, since with them we quit the mathematical for the physical order, and they presuppose a mathematical model or armature, which serves for a point of condensation, a plan which was taken into account in the construction of our instruments, and in connection with which we correct and interpret the sum of the measurements effected, by assigning the part played by accessory variations due to various physical circumstances. Only two ways are open to this search for a criterion. We can analyze the genesis of our notions in order to see if the entity in question, while not including any internal contradiction or incompatibility in its constituents, in which case it could not have mathematical existence, does not imply a condition incompatible with existence outside the mind. Thus, a logical entity, such as the predicate or the copula, is certainly not intrinsically contradictory, but it would be a contradiction to suppose its existence apart from the mind. Or, we can consider a condition which a philosopher knows applies to the reality of mathematical entities. He knows, in effect, that for these entities to exist outside the mind implies sensible existence, which is repugnant to the state of being constructed in imaginative intuition freely and purely representing to itself what is quantitative without a fortiori any possibility of its positing in sensible existence, the condition of direct intuitive constructibility. Now, among the systems of geometric entities which are called Euclidean, Riemannian, etc., space, the three-dimensional Euclidean space alone is directly constructible in intuition, the others only satisfying the posited condition by the intermediation of this space. The plan of the thermic universe invented by Poincaré, and in which we should have adopted from the beginning Lobachevsky's geometry, the highly simplified successions of sensation imagined by Jean Nicod, which would endow a fictive subject with the idea of the most diverse geometries, confirm by a kind of counterproof this privilege of Euclidean space. In order to present as natural to a thinking subject another geometry than that of Euclid, we have to imagine a universe which in itself is a rational being, as chimerical as an animal rationale alatum. Finally, if we are assured by intuition, as has been already pointed out, that the Euclidean entities, and in consequence the others, are free of internal contradiction, it is because intuition began with the assurance that in excluding the others, the former are well able to exist outside the mind in the nature of things. On the other hand, it is possible to show that if it is possible to pass from the non-Euclidean spaces to Euclidean space, and inversely by mathematical transformations, it is because in fact the non-Euclidean geometries presuppose the notions of Euclidean geometry, not certainly in their proper structure and logical development, but as a foundation for the logical coherence of the entities which they construct, and as the psychological basis of conceptualization. The process of generalization, which finds its fulcrum in Euclidean geometry, results indeed not in more extended generic concepts of which the Euclidean, non-Euclidean, non-Archimedean, etc. concepts would be the determinations, but in analogical concepts which include the one as the others, and of which the Euclidean concepts represent the analogized principle. From this point of view, we must necessarily say with Hamelin at bottom, non-Euclidean geometry is not self-sufficient, and that the non-Euclidean, non-Archimedean, etc. entities have the foundation of their logical existence in the Euclidean. The non-Euclidean spaces can then without the least intrinsic contradiction be the object of consideration by the mind, but there would be a contradiction in supposing their existence outside the mind, and thereby suppressing for their benefit the existence of the foundation on which the notion of them is based. Either way, we are thus led to admit, despite the use which astronomy makes of them, that these non-Euclidean spaces are rational beings, and that the geometric properties of existing bodies, those properties which the mind recognizes in the elimination of all the physical, are those which characterize Euclidean space. For philosophy, it is Euclidean space which appears as an ens geometricum reale. But by the words real space, a totally different thing can be understood, as describing space insofar as it is occupied by existences and physical actions, and which is made up of the physical, not geometrical, properties of bodies, their activities, and their causality, like a network of tensions of heterogeneous qualitative intensities. This is space no longer considered mathematically or geometrically, but physically. It is a qualified space, and the determinations which it admits are due to what there is in space, to what fills it. The philosopher thus distinguishes, and for him it is a capital distinction, between physical and geometrical space. And he can forecast that, in this extended sense, as physical space, that real space is not Euclidean, neither homogeneous nor isotropic, since Euclidean space is precisely that, purely mathematical one, which the mind considers after the elimination of all physical content. It is most important to realize that in speaking so, the philosopher, by the very fact that he opposes the physical and geometrical as two irreducible orders, looks on things in a way wholly different from that of the new physics. Faithful to the essential spirit of modern science, the latter tends, however far from this end it remains, to absorb itself in geometry. Thereby it has abandoned the absolute discrimination between the physical and the geometrical equally, with the search for physical causes in themselves or in their qualitative reality. The mark of genius in Einstein is that he has bent, in order to advance freely along this road, geometry itself to the needs of physics, and conceived of a space whose geometric properties are able to account for all the phenomena of gravitation. The continuum of the thus extended universe so becomes non-Euclidean and four-dimensional, where time and space are no longer independently measured, but form an indissoluble complex. The geometrical properties of so conceived space-time are themselves modified by the matter which occupies it, i.e., by what is able to disturb the measuring instruments of our exploration: clocks, graded rules, light rays, compasses, electroscopes, etc. And the movement of the stars is produced in following the natural tracks which are the geodesic curves of this space-time, a curvature which the presence of a material mass further crinkles in, the planets so turning in a sort of funnel due to the incurvature of space in the neighborhood of the sun. Newtonian physicists have accused this synthesis raised on an immense assembly of measurements culled from nature and confirmed by numerous verified previsions of being a made-up affair. They have lamented the abandonment of the search for the physical forces which should explain natural phenomena. As Cartesian physicists saw an avowal of impotence in the substitution of attraction from a distance for rotatory movements, they in their turn see a similar avowal in the substitution of geometrical curvature for mechanical force. They forget that modern physics entered on such a path from its birth. It is in avowing, not certainly explicitly, for in the beginning it believed itself to be a philosophy of nature. Its impotence with regard to physical causes considered in themselves or in their essence, that it began the composition of a mathematical myth of the physical world, which liberated for it the secrets of this world in the form of enigmas. The forces of classical physics appear from this point of view like a precarious compromise between the causes of philosophy and the purely empiriometric entities of a science of evolved phenomena. And it must be said that the new physics has accomplished a step of major importance in the progress towards the scientific conception of the universe, in exhibiting at once radically and explicitly this renunciation, by physico-mathematical knowledge of the search for physical causes taken in themselves, and its profound tendency to emancipate itself completely from philosophy. But this liberation from philosophy must not itself be taken for a philosophy. There are two ways in which it is possible to interpret the conceptions of the new physics philosophically. The one is to transport them literally, just as they are, onto the philosophical plane, thus filling the mind with metaphysical confusion. The other is, in order to understand their bearing, for the mind to detach the noetic value in them. In the one case it will be said, not only which would be wholly legitimate in the vocabulary and from the point of view of the physicist as it has been defined above, but in a philosophical sense, that the space postulated by the new physics is geometrically real, and exhibits the geometrically real properties of the corporeal world, which would result, in the degree to which the new physics achieves or will achieve the explication of the universe by the geometric properties of the space invented for that end, in the justification in itself of a purely geometrical exegesis. To distinguish physical and geometric space from one another would then be to distinguish one geometric from another geometric space, to distinguish the properties of geometrically real space when occupied by matter from the same geometrically real space when void of matter, mass or energy, quantity of motion, pressures, and only occupied by something of the kind of that immaterial ether beyond which we have not got. At the same time, geometry itself, its proper object being misunderstood, like its epistemological independence and its higher rank of abstraction, would be regarded insofar as it is not an empty pure form as an experimental science, which would only hold, as an objective content which makes it true, the physical entities and mensurations thanks to which the mind chooses as real space, among the various formal spaces which it is pleased to imagine, the one which agrees best with the widest and most perfect geometrization of physics. Under the pretext that space is a network of distances, but which geometry ideally and deductively measures, the assumption would be made of having given geometry an object, geometry as a natural science, in this network of distances materially and empirically measured by physical apparatus. In the other case, it is recognized that the space of the new physics, void or encumbered with matter, is a physico-mathematical rational being expressly constructed to save known appearances, and which will only be modified in the degree to which errors may be found as existing between the construction already built up by the reason and the new data of experiment. This rational being is seen to be in the nature of a geometric symbol of physically real space, taking physical space in the sense given to it by the philosopher spoken of above. The geometric or metageometric symbol that best translates the reality of those physical interactivities whose ontological scrutiny has been abandoned for their better mathematical analysis. The double irreducibility, a form of value which is sacred for the intelligence, of the physical, considered ontologically in its essence, to the mathematical and of the geometrical to the mathematical, is thus safeguarded, and it is understood that the geometrization of physics can only be accomplished by introducing a mathematically transmuted physics into the heart of geometry itself, which has a so much richer crop of rational beings, departs so much more decidedly from real geometric being, that it is asked in addition to absorb it in its symbols and to mathematicize physically real being. The same considerations, mutatis mutandis, the necessary changes having been made, apply to the mathematization of the physically real in the quantum theory, though worked in another way than that of the theory of relativity. In particular, to the structure which the new physics attributes to the atom, or rather to the way in which for several years it has changed the said structure from day to day. It seems as though science tended to endow this structure, which has so become unrepresentable and at the same time detached from any ontological meaning, with a purely abstract mathematical equivalent, a more and more fictive, a more and more perfect symbol of the real nature, which is unknown in itself, of some existent thing to which the determining name of atom corresponds, so that it may know this nature more and more profoundly, but more and more enigmatically, or indeed metaphorically, in the degree to which it builds up the myth, the rational being founded in which takes its place. 2. The philosophy of nature. According to a phrase of Professor Eddington's, the physicist of today, who knows that our knowledge of the objects treated in physics consists solely of readings of pointers and other indicators, and who also knows that this schedule of pointer readings is attached to some unknown background, is much less tempted to believe than the Victorian physicist that nothing is true except what can be reconstructed by an engineer, or that physics is all sufficient. Rather, he is led to believe that a just appreciation of the physical world as it is understood today carried with it a feeling of open-mindedness towards a wider significance transcending scientific measurement, although he feels all too ill-equipped to discover for himself whither this feeling should lead. This is true not only for physics, but of empirico-logical knowledge in general. It is clear that in its essence such knowledge remains insufficiently explanatory, and with it the mind cannot be content. The philosophical or pre-philosophical substrata which the scientist himself cannot transcend are a clear indication of this. Some knowledge of being itself is needed, of corporeal, sensible and mobile being, of the being immanent in these natural realities in which the phenomenological sciences find their end and their verification, the basis of all their conceptual constructions, over which they give us practical power. Such knowledge must evidently have another object and other characteristics, build itself up on another noetic plan than what in our modem phraseology is called science. Its office should be neither the continuation of science on the same plane, in that direction, as Bergson once said, beyond science there is only ignorance, nor the decoration of the results of science with noble and vague meditations, though its rules of explanation are not those of science in the modern sense of the word. they should certainly merit the name of science in the qualitatively deeper and more authentic sense which was known to the ancients, and which creates its possibility. For the natural sciences do not only lead the mind to desire this, in themselves in their witness that nature is knowable, and that nevertheless they themselves can only know in an essentially unsatisfying way. They testify that a form of knowledge is possible, where the intelligence actualizing the mysterious intelligibility of things at a deeper level discovers in these sciences the being towards which they aspire as their natural object, always on condition that the mind can resign itself to the necessary curtailment and ascesis, and understand that in order to grasp a little of the being of things, it must renounce the will to utilize this more noble knowledge, which is yet quantitatively poorer, for any speculative or practical exploitation of the riches of phenomena. This is a form of knowledge which, even in one connection only, and in a given order, in the order of sensible nature, is a wisdom, a thing of fruition, not of usage. And all wisdom must, in one way or another, pass through the eye of a needle. It was in the quest for such philosophical comprehension that the knowledge of the natural world began, but it has taken long for it to learn the spirit of poverty. The misfortune of the philosophy of nature among the ancients was that it believed it was a science of phenomena. Let us also call by its proper name the philosophy of nature, the form of philosophical apprehension. I am here seeking to define, but let us understand that it must necessarily lay aside all pretensions to cross the frontiers of its essence and conquer the world. We are going to refer ourselves to the philosophy of nature, which in my opinion is most securely based, and which has the privilege of being in continuity with the most pure metaphysic, the philosophy of nature as conceived according to the principles of Aristotle and St. Thomas. Let us be equally well aware that it is indispensable, and not half so difficult as is ordinarily imagined, to separate those principles from the applications and illustrations for long connected with the scientific conceptions of the ancient world, and clearly see that this knowledge of wisdom, this philosophy of being essentially subject to change, is completely free in itself from any connection with an astronomy and a physics forever gone to ruins. But what concerns us here are the epistemological characteristics and conditions of the philosophy of nature. It is an intelligible being itself, however obfuscated it may be by sensible matter, that such a form of knowledge resolves its concepts. It results from a type of ontological explication open to the natural motions of the speculative intellect. It is not with empiric conditions, but with reasons of being and causes in the true sense of the word, that it is connected. It is the essence of things that it seeks to discover. Proceeding, like all philosophy, according to an analytico-synthetic method, it depends on experience much more closely than does metaphysics, and must be able to submit its judgments to the verification of the senses. But it is a deductive apprehension, assigning reasons and intelligible necessities in the degree to which it is assured of the intrinsic constituents or the quiddity of its objects. It is by this, for example, that it is able to instruct us concerning the nature of continuity and number, of quantity, space, motion, and time, of corporeal substance, transitive action, vegetative and sensitive life, concerning the soul and its operative powers, etc., and also to consider the ontological disposition of this universe, i.e., as Aristotle does at the end of the Physics, its relation to the first cause, and the adjustment between the necessary, the contingent, and the fortuitous in the course of its events. If we wish to define the philosophy of nature, we must say that it is a form of knowledge which has as its object, in all the things of corporeal nature, mobile being as such, and the ontological principles which give the reason for its mutability. It was Aristotle who founded this science, Aristotle who showed that an ontology of the sensible world is possible, not so far as it is sensible, but in so far as it is the world of changing being, and that it implies in its structure intelligible invariants dependent on specifying forms. While metaphysics embraces the whole domain of intelligibility, not as such immersed in the sensible, physics, in Aristotle's meaning of the word, embraces the whole domain of the intelligible, which is so immersed. In the conception of the ancients, all the sciences of the material world make part of this form of knowledge, a mark of a singular optimism and a most candid philosophic imperialism. With their minds first of all fixed on philosophy, they had a tendency to absorb all the other natural sciences into it. In certain spheres, nevertheless, these sciences had already come to the knowledge of their own proper methods and autonomy, but they regarded these as a special case of scientia media, middle knowledge, envisaged as the mathematical treatment of questions of natural philosophy, and in the degree to which otherwise the philosophy of nature filled the place of a scientific systematization of the detail of phenomena. This too often gave rise to explications of an extreme analytical insufficiency, which was often only verbal. As I have had occasion to point out in a previous chapter, it is very important not to forget that, as St. Thomas often says, the essence of sensible things remains in general hidden from us by reason of the matter in which it is included. It is only in the mathematical order that we can consider a world of essences as discoverable, which is why it is the most dictatorial and sumptuous form of human science. In the physical order, it is indeed possible to reach certain essential and specific determinations concerning man and the things of man, his powers, habits, etc. But below man, at most times, the element of resistance to intelligibility, which belongs to matter, which renders corporeal natures opaque to us, and knowledgeable by signs rather than by properties, in the ontological sense of the word, causes the essences to remain hidden from us in their specific nature. It follows from this that the philosophy of nature cannot reach to the ultimate specific diversities of bodily nature, and this implies a grave restriction of the philosophic optimism of the ancients. When it is a question of the distinction between certain very widely extended spheres, living and not living bodies, animals and vegetables, men and irrational animals, the philosophy of nature is well able to grasp the essential differences. There we are in a region accessible by the philosopher. We achieve truly philosophical certitudes in the very order of typological discrimination. In other words, we know that there is an essential difference between vegetable irritability and animal sensibility. We know that the immanent activity by which the living organism builds itself up, sensation, intellection, reveal quantitative principles, which enable us to enter into the inward structure of the beings under consideration. We know that the body as such is built up by two complementary ontological principles, the one purely potential and determinable, the other specific and determining, which we call the prime matter and the substantial form. But the philosophy of nature must remain content with certitudes of such a high degree of universality. It must leave all questions of the diversities and specific particularities of the world of bodies, all the detail of the workings of sensible nature, in the hands of that knowledge which Leibniz called symbolic or blind, and which here I have suggested calling empyreological. That knowledge can enter into the fullest detail. It is the essence that escapes it. If it is a question of deciphering the multiplicities of becoming, the interactions which make up the splendidly multiform and close-knit play of nature, the philosophy of nature can doubtless have indirectly a heuristic value in the stimulations which it is able to exercise in the minds of scientists, above all in the case of those sciences which I have called empirico-schematic. But in itself, and in its own proper field, it makes no such claims. There is no other science of the phenomena of nature than the empyreological, and that science is not a philosophy. It must here be stressed that apprehension is only perfect when we can know things, not only in a more or less indistinct fashion, leaving off at generic determinations, but in descending to the most ultimate specific determinations. If metaphysics is a perfect apprehension, I shall return to this point later, it is because its specific object, being as such drawn from things by abstractio formalis, is not a genus, but a transcendental, which taken as such is at the ultimate degree of logical determination. What then is the case with the philosophy of nature? Its object is not the ens in quantum ens, the object of the metaphysician. Neither are the specific natures of the world of bodies, as we have just seen, its object. These natures would be the specifying object of the natural sciences, if these sciences could, as they cannot, attain to it. They stop at an empiriological knowledge. For all that the philosophy of nature, no more than metaphysics, does not only bear on simple generic determinations. In reality, it considers corporeal and mobile things from the standpoint of the transcendental being with which they are saturated. In this way, it shares in some degree in the light of metaphysics, as our souls also share, in a way, in the nature of pure spirits. The specific object of the philosophy of nature is, in corporeal natures taken as such, the ontological mutability and the formalities by which the mind can discern a difference of being, corporality, quantity, movement, life, animality, etc., which is sufficient to assure to it its distinction from and autonomy with regard to the experimental sciences. But on the other hand, sensible or mobile being is not complete in itself, only has the integrity of its determination in specific natures. The experimental science of nature and the philosophy of nature are two distinct forms of knowledge, but each incomplete, ruled by different laws of procedure, the one above all of the intelligible, the other above all of the sensible, and which result, well or ill, in self-completion. It is by this that they both belong to the same degree of abstraction, although, from another point of view, as we have seen, the philosophy of nature may be essentially different from the natural sciences. I could gladly compare the relation of the philosophy of nature with the sciences of nature with that of the rational soul with its body. In itself, the former is independent of the state of development of both the latter and their hypotheses. It rests on philosophic facts, which are much more simple and fundamental than scientific facts. Nevertheless, to insist too exclusively on this independence, as the philosopher is often inclined to do, is to risk losing sight of the intimate and substantial union which should rule over these two sections of the knowledge of the sensible world. For 3 centuries, during which the natural sciences have been subject to the fascination of a mechanistic metaphysics, the authentic philosophy of nature has been in the condition of a disembodied soul. It has so undergone a purification from many defects. Today it has come once more in contact with experimental science. This contact is both natural and necessary. If the philosophical facts on which natural philosophy is based, e.g., there is a real specific diversity in the world of bodies, there are substantial mutations, living organisms are endowed with an activity which returns upon itself, etc. If these philosophical facts can be established as starting from common observation, subject to a philosophical criticism, nevertheless it is proper that in relation to the self-development of the positive sciences, they should be illuminated also from the standpoint of scientific facts, insofar as the latter can be disengaged from theories. In themselves, scientific facts are incapable of producing any philosophical decision, but the rightful penetration of these objects and their philosophical principles, like the light of the active intellect striking on phantasmata, can release in them the philosophical content with which they are pregnant. Permanent as are its essential determinations, natural philosophy must thus also bow to the law by which things grow old and are renewed, of fading and transformation, imposed on the fleshly garment which it receives from the experimental sciences, and thanks to which its material supply of facts accumulates so marvelously, while it also must free itself from certain, not philosophical but general or vulgar, representations, which have been taken for pre-scientific interpretations implied by the familiar world of the senses. The doctrine of hylomorphism, for example, is as true today as it was in the time of Aristotle. It is its vocabulary and its exemplifications which have worn out, not its substance. Only the 4 elements of the old world have been replaced by the 92 elements of Mendeleev's table, which correspond to very different scientific notions. We have a much closer knowledge of this tribe of elements than the chemists of 100 years ago. And it seems more than possible that they all derive from the hydrogenic atom by a series of changes which a philosopher must necessarily regard as substantial mutations. Radioactive phenomena furnish us with proofs of such changes de natura in the world of bodies. Not doubtless in itself a pure and simple scientific verification, it is for philosophy, not science, to establish a fact whose formulation implies the notions of substance, nature, species, etc., metaphysically understood, but an indication or sign empiriologically remarkable which the philosopher acting with prudence can disengage as such. The existence of the microstructure of matter is a definitely established fact, which leaves open the rightly ontological question of the essence of matter. If science incessantly revises and renews its conceptions of spatio-temporal organization and the properties of the atom, it is by affirming in so far the existence of the so-named primitive complex. And indeed, this assembly of empiriological forms of knowledge agrees rather with the ontology of Aristotle than with that of Democritus or of Descartes, and I might add, doubtless much better than the experimental conceptions in favor with the alchemists of the Middle Ages. Some complementary elucidations. But how is this possible? Professor Eddington, with his vivid descriptive imagery, declares that a body is a world tube of 4 dimensions, separated from the rest of space-time by a more or less sharp limit. This is far enough away from the world of Aristotle. From Aristotle's scientific ideas, yes, but what we are considering is his philosophy. Whether an elephant be an isolated world tube with 4 dimensions or a block of flesh and blood composed of 4 elements and the 4 primary qualities, in one case as in the other, there is no resemblance between the idea, which is expressible in an image or in a spatio-temporal scheme, and at least reductively figurable, which science or common sense has of this animal, and the essentially unfigurable and purely ontological conception which belongs to the philosopher in his first statement of the principles which constitute the substance of the same elephant. Primary matter and substantial form belong to another nomadic universe than this block or this tube. The theory of hylomorphism is favored by neither the one nor the other, for it is based on another foundation than these images. Whether it be a 3-dimensional block or a 4-dimensional tube, the elephant must necessarily perform that operation, which the man in the street and the scientist call by the same name, though seeing it under very diverse terms, which is known as eating. And it must necessarily end by that phenomenon which both call dying. And the philosopher, who knows that the elephant in question is an individual substance, a thing in itself, specifically different from the vegetable substances which it assimilates by nutrition and the inorganic materials into which its body can be decomposed, is constrained to seek for the subject of these substantial mutations in a radical potentiality, which, following Aristotle, he could look to a higher name, he will call prime matter, of which naturally he will be incapable of either describing the features either in a space of 3 dimensions or of 4, for it has no features, or of explaining how, at once unformed and transcendentally determined by the specifying form which joins with it to compose a single substantial being, it can clothe itself with accidentals and become accessible to the calculations and observation of the ordinary man under the appearance of a compact mass, at once tangible and visible, or a prodigious swarm, which is for all that unrepresentable, of protons and electrons, i.e., of undefined particles, and waves in motion in a given space, which are all only statistical symbols. An insoluble hiatus perpetually attests the difference of order which distinguishes philosophical from scientific explication, both being legitimate and necessary. I might point out in parenthesis that if they had been sufficiently observant of this fact, some eminent scientists would not have been led to confound substance, in the philosophical sense of the word, with substance, in the common interpretation, as it is imagined in terms of that first outline of scientific knowledge, which is common sense observation, and thanks to which we know that the table is not penetrated by the sheet of paper that we lay on it. According to the principles of the argument which we have been pursuing, the Einsteinian universe of 4 dimensions and its curvature, like the electron or photon of today, must necessarily be regarded as pure physico-mathematical rational beings founded on the real. The question then arises of what form of relation can be sustained by philosophy, no longer with the facts or entia realia more or less completed by the reason, but with pure concepts in the well-founded myths of science. Here, a point previously outlined must be completed. In my opinion, natural philosophy must take over the entire deposit of the experimental sciences. But if it can be based on the facts established by these sciences, as on a strange substance which it appropriates for its own use, it is obvious that it cannot look to ask from physico-mathematical rational beings a means of elucidating the ontological nature of things in themselves. It is in another way that it should make use of them, in the degree to which each is an element of the image of the universe elaborated by science. For the philosophy of nature cannot dispense with scientific imagery. It needs the image. Can the word still be used when it has become unimaginable? Or the symbol which the science of its day fashions of the world? Moreover, natural philosophy is aware that certain of the more serious entities which it itself constructs are myths, masks of the real which it proffers to the mind. And it is its duty to remember to make these, most of all because of the mathematical rational beings which serve in their construction, more and more unrepresentable by the imagination. By this heroic remedy, it will escape from the temptation to represent, like a Descartes or a Democritus, the secret fibers of nature according to the gross plan of the models which our eyes and our hands can see and grasp. Science, which is absorbed in the world of the sensible and the figurable, and which is nevertheless led by its very progress, not to transcend, but rather to dissolve it in what then only reductively belongs to the world of figurable, holds in this a great lesson for the philosopher. Should he not have recognized for himself that the primary spatio-temporal elements of the world of bodies, by the very fact that they make up the complexes which fall naturally within the sphere of our senses, cannot resemble these complexes? The world which is constituted by them cannot resemble anything known by our senses. To penetrate into it is to pass a shadowy threshold disturbing to the imagination. And in the lack of fuller knowledge, the unrepresentable myths of science have at least the merit of reminding us of this fact. What nevertheless can the philosopher make of a myth? Doubtless nothing but another myth, this time a philosophical one. There is no other way in which natural philosophy can assimilate the myth securely based on physico-mathematical apprehension into its own order, than by itself turning to the making of myths. Do not we know that in a way the philosopher is a lover of myths? Philosophicus est aliqualiter philomythes. The philosopher is somewhat of a lover of myths. An immense field is thus open to the creative imagination of the philosopher, e.g., when he wishes to interpret in the light of an otherwise well-established philosophical doctrine, such as that of hylomorphism, the provisionary image which science fashions of the microstructure of the atom. Hardly will he have invented a sufficiently likely hypothesis, assuming, for example, that substantial form informs, like a central nucleus, the intra-atomic ether and the electrons which circle it. When the theories of Rutherford and Bohr, on which this interpretation is grounded, will begin to fall into dissolution, he must necessarily readapt it or invent another. The philosopher can exercise his wits on a four-dimensional universe, or the ether, of which today physicists are careful not to speak, although it still seems that they will find some difficulty in getting beyond it. But if in the course of such work he is convinced that he is occupied with philosophy, in the rightful sense of the word, we can only regretfully compliment him on his courage. Although there is no continuity of rational explication and the understanding of things between physico-mathematical theories and natural philosophy, we can so see that a secondary connection can be established in regard to their imagery. Insofar as it is true that it is of the nature of natural philosophy to add to the field of directly philosophical knowledge, and that it requires by its own essence a region of philosophical myths, destined to accord with the well-founded myths used in physico-mathematical theories, as the completion of its union with the experimental body composed by the sciences. It is a point very worthy of attention that the world of sensible nature is the only one in which we find our apprehension shared at once by a philosophy and an experimental science, the one being the soul of the other's body. Such a duality is found in no other universe of intelligibility. Mathematics has no ontological soul. It has only an abstract and ideal body. Metaphysics has no empirico-logical body. It has only a spirit. 3. The mechanistic theory. If the preceding analyses are correct, we can see that the central fault of modern philosophy in the sphere of natural knowledge has been to give an ontologically explicative value to that form of mechanistic attraction immanent in physico-mathematical knowledge, and in taking this for a philosophy of nature. This it is not. It is an empiriological analysis of nature, mathematical in form and direction, an empiriometric analysis. Though it is true that such an analysis must inevitably build up for itself a world of explicative entities destined to sustain mathematical deduction, it is clear that, on the one hand, this world will be, as we have seen, pseudo-ontological, abounding in rational being, and on the other, that it will be orientated towards the mechanistic as its ideal limit, although never wholly attaining thereto, since all the irrationals which science is bound to admit are opposed to an effective mechanistic reduction. Mechanistic representations are in effect the sole residuum of ontological explication able to enter into the substance of mathematical physics itself. It is therefore with them that the physicist endeavors to construct the system of principles and reasons of being of a physical or geometrical order of which he has need. But in that case, it is a question of provisional representations, whose whole value exists, not in relation to the real envisaged in itself, but with regard to the mathematical relations which they sustain. A question not of philosophical, but of a methodological mechanism, at once problematic and auxiliary. It would be possible for philosophy to retain this approximative spatio-temporal image, this well-founded myth which has contributed to build up the structure of that universe and its elements. It cannot endow it with an ontologically explanatory value. In what degree, then, does the present crisis of physics imply new points of view? First of all, the new physics seems to have turned its back on mechanism. This is true in the degree to which we may take the word mechanicism in a strict sense, as it is understood by classical geometry and Descartes' aphorism. The whole of my physics is only geometry, but the deepest center of mechanistic theory is not geometricism, it is mathematicism. And on the other hand, geometry itself, in the degree to which it becomes abstract, tends to become coextensive with mathematics. We can say that the new scientific conceptions only make more daringly manifest the scheme of transmuting physics into a universalized mathematics, that the geometrization of physics may reach this aim through a refashioning of geometry under the influence of physics, which reduces it all the more easily for the care that has been taken to penetrate it. I have already pointed out. But that in effect implies little. Also, these crises and transformations of the mechanistic ideal must not be taken for its decease. The physicist will always remain attracted by the ideal of a unification of all knowledge concerned with the physical world in a single science which will be expounded in geometric or quasi-geometric terms. And as this tendency is not towards a philosophical geometricism, he will accept without difficulty, in order to achieve more nearly this ideal, all the reconstructions which the apprehension and symbolization of the physically real impose on mechanics and geometry in themselves. It is here that the epistemological superiority of the new physics becomes patent in the eyes of the philosopher. It exhibits more clearly than classical physics, makes obvious to all, the purely methodological and supplementary character of the mechanism or Pythagorism of the scientist. On the one hand, it rehabilitates the reality of moon, which strict mechanicism has destroyed, a recognition of that irreducible reality, which is, it seems at least to the eyes of a philosopher, at the origin of the theory of relativity. But then, in order to safeguard the geometrization of physics, it finds the need to mobilize measured dimensions, the pointer readings made by the observers of various systems of reference, to abandon the spatially unique and absolutely immobile frame which the mechanistic philosopher took over from mathematics to hold his cosmos, and within which he saw all the movements of the universe as variations of a pure ideal spectacle. For, attaching an ontological value to geometricism, he has no means of philosophically considering movement as real. The new physics has no more thought for the philosophic reality of movement. That is not its affair. It is perforce that it finds a place, with the assistance of numerous rational beings, for this reality in its physico-mathematical synthesis. And by this very fact, it attests that the mathematicism towards which it tends has not the slightest ontological claim. On the other hand, it has been compelled to recognize a certain disparity between the notions and principles applicable to phenomena in our large-scale dimensions and those applicable to the atomic scale. This is so because, as was recalled above, in the atomic scale the individually taken material particles cannot be subjected to both a continuous observation and determination. And if it is true that the resolution of concepts in empiriological knowledge takes place exclusively in the sphere of the observable and the measurable, and that in consequence, in such a form of knowledge, a concept only has meaning with regard to the experimental circumstances and method which serve to define it, it follows that, in the atomic scale, the very notion of the empiriological object is modified. It designates something observable and measurable, a possibility of observation and mensuration. But this very observability and measurability are fundamentally different. Thus is it not astonishing that the entire organism of scientific explanation should differ in the two cases, and that it should, for example, here and there admit of exigencies mutually incompatible with the law of causality. This capitally interesting result makes evident the fact that the mathematicism, above all statistical, and in the case of microphysics, indeterminist in form, and the geometrization of physics have lost all philosophical claim, any pretension of telling us the nature of material things in themselves, unless physics should itself interdict its proposition to us under two different scales. I do not say of two different images, that goes without saying, but of two conceptions of the same world which are rationally heterogeneous, whose sole continuity is supplied by mathematical formalism. Dangerous liaisons. This is not the place in which to try to reckon up the opportunities which the new physics offers to philosophy, either in the order of facts or of the apologetic conveniences, so to speak, which it presents. I would only proffer certain brief suggestions. Is Carnot's principle, which Professor Eddington writes of with such singular charm, and which is not an acquisition of the new physics, but which inextricably subsists in it, at least in the macroscopic scale, able to cast any light for us on the problems of the origin of the world? The deceptions which have resulted from some philosophical attempts, the diversity of the opinions entertained by scientists as to the degree of estimation in which the principle itself should be held, call on this point for the most careful reserve. But the second law of thermodynamics offers other possibilities to the philosophy of nature, in particular with regard to the living organism. Is it not one of the marks of the irreducible specificness of the latter, that without violating this principle, rather on the contrary, applying it to its own use, it utilizes the universal process of the diminution of energy to variously recompose both its order and organization, to raise for a time the degree of being? I do not say with regard to the quality of the energy, for life does not belong to one special form of energy, but with regard to the perfections of a higher, properly biological or psychic order. Material. Life is a constructive fire which feeds upon decay. On the other hand, certain conformities seem to create between the philosophy of nature and the image of the universe elaborated by the new physics zones as it were of affinity. The hope of deducing the diverse physical constituents of the world of experience, starting from the minimum of primary notions, selected with a freedom possessed by no metaphysician, the idea of a finite universe, which is nevertheless, as a result of the curvature of space without limits, and which, according to the most recent hypotheses, is expanding, still more that of the discontinuity of energy and the variability of mass, find abstraction being made of their particular and scientific value, an a priori complicity, so to speak, in natural philosophy, and I do not only speak of a necessarily Cartesian philosophy. Indeed, it seems sometimes possible to discern in certain conceptions of the new physics, not certainly the smallest substantial likeness, but a sort of stylistic kinship with the antique accessories of the peripatetic workshop, such as the natural state, condensation and rarefication, or the difference of nature between the matter of the heavenly bodies and that of corruptible bodies, of which the distinction, which is even more sharply drawn, between the matter of the physicist and his non-material ether, insofar as he admits its existence, seems like the modern reproduction. It is notable, on another side, that one of the effects of the present-day revolution in physics has resulted in its enlargement, as Vernadsky pointed out in a remarkable address to the scientific societies of Moscow and Leningrad with regard to the phenomena of life, to such a degree that the planetary importance of these phenomena will thereby be more easily recognized, and the typical traits of their physico-chemical behavior, e.g., irreversibility or again dissymmetry, passing over into the world of the inorganic where they have been neglected, will perhaps supply science with new ways of thinking of the physical. How, finally, can the imagination of the philosopher or of the poet resist the fascination of these light atoms which condense or transform themselves into heavy atoms in order to radiate as light or as heat, of this way in which mass is measured by its internal energy? These stars which by ceaselessly reducing their mass, which is to begin with so enormous, and which will completely exhaust themselves after billions of years, pour forth in the present energy into the universe. How fail to find here great symbols of the mystery of the very life of the spirit? But let him not forget how erroneous it would be to try to erect a philosophy of nature and a fortiori a metaphysic on the theoretic conclusions of modern physics and its explanations of the world, as if these conclusions and explications could be taken as ontological foundations, could be used as such by the philosopher without their previous subjection to a rigorous critique. That was the error of Spinoza with regard to the physics of his time. It seems to me that, from very different standpoints, Bergson and, if I have rightly understood him, Professor Alexander are neither of them safe from this danger, the one seeking to free a so-called durée créatrice, creative duration or creative time, immanent in the world of the physicist, which the physicist would misunderstand. The other making of that world the matrix, as it were, from which the worlds of more and more qualified, more and more solid realities emerge. There is no less self-reception in the assumption that it is possible, misled by the various advantages of which I have spoken, to draw from the new physical theories a philosophy of nature, or for instance in the desire to find in the indeterminate conceptions of contemporary physics any argument against philosophical determinism. The refutation of the latter must be philosophical. However important or significant the ideas of Heisenberg, for example, may be to the theoretician of the sciences, they have absolutely nothing to do with the problem of liberty. Doubtless they may assist in destroying some scientific fictions, but it would be a misappropriation to wish to utilize them directly in an apology for free will. They have no more value in that region than the clinamen of Epicurus and Lucretius. I do not fail to appreciate the important bearing of the reversal of values produced by the conceptions of the new physics, in what is concerned not only with science itself and its own interests, in its general human and intellectual aspects, in the social and economic worlds. From this standpoint, which I might call the epistemo-sociological, science is no longer considered in itself as being true or false, in the determinations which follow in themselves from its exigencies in the knowledge of things. It interests us as a collective formation produced here and now in the minds of men, and producing in the latter, like a ferment or a center of organization, varied reactions associative rather than rational, which are accidental with regard to the sciences themselves. Thus classical physics, per accidens, gave force to the illusion of an integrally mechanistic explanation of the universe, so-called scientific picture of the cosmos, where consciousness and life must necessarily be subject to physico-chemical processes, and these again to mechanics, and where, thanks to that unique formula of which Laplace dreamed, the calculation of the movements of material points according to Newton's laws of attraction should have allowed in theory, if not in fact, the prediction of all events and all the history of the worlds of brute matter, of organic life, and of humanity, of the development of thought or the trembling of a reed, even as of the motions of the stars, set up, like a mirage in the skies, over the minds of investigators, who held that they could not even begin to set to work without paying some tribute to it. In abandoning classical mechanics still more, in enunciating the principle of indetermination for phenomena of the atomic scale, and by affirming that it is contradictory to suppose that science can follow and determine at each instant the bearing of an individual corpuscle. In other words, that it is not possible to know its complete past and thereby to foresee its future, the new physics has done away with the very reasons for the existence of all this pseudo-philosophy, which looked on the mind and free will as a scientific scandal. This is no small achievement from the standpoint of the sociology of the intelligence. Physics no longer offers any moral objection to free will. But this result in itself has no formal and intrinsic philosophical value, for it would be false to hold that mechanics and classical physics as such implied the negation of free will, and the mechanistic postulate of the possibility of explaining everything by the laws of movement, in other words, by reducing everything to the displacement of corpuscles, any more than any other metaphysical conception. The quarrel between determinist and indeterminist mechanics is outside the field of philosophical problems. It is equally impossible to find, in the indeterminism of the new corpuscular mechanics, a philosophical significance otherwise than by tying it up with a metaphysical error. Then it is imagined as mediating against the axiomatic value of the principle of causality, philosophically understood. I have indicated above that the principle of indeterminism introduces a lacuna into the field of scientific causality, or more exactly, among those substitutions of causality reached by physico-mathematical apprehension in its reshaping of the concept of cause. But, if it is so, it is precisely in the degree to which science has left behind an ontological standpoint and abandoned thinking of phenomena sub ratione entice, under the aspect of being. We have abandoned strict causality in the external world, writes one of the most distinguished theoreticians of the new physics. In place of this, it would be better to read empiriometric science, that apprehension which resolves all concepts not in being, but exclusively in the measurable, and which has now perceived that the entire physical world cannot be exactly measured. To endow this renunciation, which only has a meaning in the empiriological field, with philosophical value would be a strange misunderstanding. It is impossible for human science, which observes and measures things by material instruments and by physical experiment, and which can only see an electron by encircling it with light, to know determiningly the way in which a corpuscle will behave at each instant. But suppose the existence of a pure mind, which would know without material means, and so also without empiriological concepts, the behavior of this corpuscle at each instant. Such a mind would see the strictest application of the principle of causality in the full ontological sense. This hypothesis has no significance for the physicist, but if it has no significance for the metaphysician, it is because he has not yet learnt metaphysics. Neither let us indulge in the hope that the social bearing of scientific and philosophic discovery will show itself as any more sensible in the future than in the past to the distinctions, which are nevertheless indubitable, which are here in question. The new physics will act on the general mind in the same irrational way as classical physics, by associative influences or sub-intellectual induction. It will raise up in its turn, to all appearances, the larva of a philosophy, a new scientific picture of the cosmos, which will only save us from the errors of the first at the price of the inordinate prestige of the new, and which doubtless will only prejudice public opinion in favor of contingence and liberty, in stamping the substantiality of matter and the principle of causality with discredit. As for myself, I know that physico-mathematical explication cannot be in continuity with philosophical. From this point of view, we must allow the reason of those who think that it would be prudent to interdict the entry of philosophers into the workshop in which the new quantum theory is built up. In fact, this physico-mathematical universe is a closed world, where geometricism, understanding this word in the widest sense, insofar as it conforms to the ideal of the new physics as to that of the old, where mathematicism produces a pseudo-ontology, substitute both natural philosophy and metaphysics. This pseudo-ontology plays only a methodological and subsidiary part, but it is there, and thanks to its rational beings founded on the real, it builds up a system of total explication which makes this intelligible universe a whole shut-in on itself. The philosopher will explain how this universe of the physicist comes to be built up. He will borrow its materials. It is also, as I have said, from it that he will ask for his image of the physical world, in accord with which he will in his turn fashion his myths, in the Platonic meaning of the word. But he will have superimposed on this universe a different one. Ontology and empyreology in the study of the living organism. The case is otherwise for the other experimental sciences, above all, for biology and experimental psychology, whose essence does not consist in a mathematicization of the sensible, and where the mode of resolution of concepts and of explanation primarily belongs to the epistemological type, which I have christened empirico-schematic. In saying this, I certainly do not mean to say that these sciences reject any mathematical treatment of the observed subject. Far from it. If such treatment finds its prime field in physics, since corporality as such is ontologically soaked in the quantitative, it nevertheless penetrates wherever the shadow of quantity extends, or finally that of matter, and this shadow reaches to the things of the soul itself. But in the degree to which we rise above the particular world of physics, and the object gains in richness and ontological perfection, in proportion, the quantitative aspect of the subject under consideration becomes, I do not say less real, but less significant and more subordinate, and the science in question less easily reducible to a form of interpretation, which is in principle purely mathematic. It would be assuredly vain to pretend to diminish the part which physico-chemical analysis, and in consequence the calculus, already plays in biology, a part which every day only increases. In a region as irreducibly biological, as governed by concepts of form and of organic totality, as experimental embryology, Brachet is able to write, "The physico-chemical epoch is only in its infancy, but there is no doubt that the future belongs to it. The fact remains that it represents the material conditions and means of study, and as all the facts of the living organism are physico-chemically built up, this analysis can and should advance indefinitely. Does this imply that it can ever exhaust biological reality? Assuredly not. For if everything in the living organism is done by physico-chemical means, everything is also done by the soul and its vegetative potencies as the first principle. Rooted in a substance endowed with immanent activity, physico-chemical energies there produce in the degree to which they are instruments for the soul and its vegetative faculties, and without violating the laws of inanimate matter, effects which surpass what they could do by themselves alone, in the sense that they actuate and raise ontologically the subject itself. And without doubt, it is possible to conceive of a form of experimental biology which, consenting so to speak to a kind of amputation, would turn exclusively to the energetic and physico-chemical analysis of living phenomena and thus be orientated towards an entirely mathematic and mechanistic ideal, leaving all the rest to natural philosophy. Whatever orientation may in fact direct modern biology, I hold it nevertheless for certain that in the experimental field, an empiriological analysis is both possible and requisite, which sets itself to penetrate vital phenomena as such, and which, while remaining clearly distinct from natural philosophy, makes use of experimental concepts, which are strictly and irreducibly biological, and subordinate to energetic, physical, and chemical concepts. While, for example, the philosophy of nature makes a place among its explanatory concepts for the concept of finality, the facts of biological finality only present for physico-chemical analysis, an irrational requiring to be reduced as far as possible. While for the rightly biological analysis of which I have been speaking, they result in an empyreological concept which could be described by the same name of finality, but which would have to be entirely recast and emptied of all its philosophical significance, and which, leaving on one side the whole use of finality as a causal explication, would simply express that general pre-explicatory condition that the functions of the living organism, and the use which it makes of its structures, supply for the continuation of life. As to the concepts of the soul and the vegetative potencies, they play an indispensable part in natural philosophy, but they remain outside the field of properly biological experimental analysis, as they are outside that of the physico-chemical analysis of living phenomena. Thus it is obvious in what sense I meant that biology did not consist in a mathematicization of the sensible. However largely biology may, and has the right to, make use in the material analysis of life of mathematical means, these remain a simple instrument. It knows no obligation whereby it must necessarily substitute reconstructed quantitative entities for the sensible and qualitatively determined objects furnished by observation. It remains an autonomous science with regard to the laws of mathematical explication. Borrowing at will from mathematical methods, it nevertheless does not constitute a mathematicization of living phenomena. Sciences such as experimental biology and psychology set out to attain a knowledge of affective or cognitive or vegetative life, whose ontological indications are doubtless very weak, since being is only considered as a simple basis of the observable, and the typical law of apprehension remains that of saving sensible appearances, but which nevertheless does not recompose its object in the field of mathematical ideality by withdrawing it as far as possible from its reality in the world and nature of the sensible, and which as a result can enter into a certain theoretic continuity with philosophical explanations. If these sciences may happen to compose explicative rational beings, for all that it is not in order to construct a universe of deduction, which is substituted for that of real beings, they remain imperfectly deductive. Instead of making a closed universe on which the universe of natural philosophy is superimposed, they rather make up with natural philosophy two stages, or conditions of the same universe. Insofar as they approach nearer to the purity of their type, they tend, as we have seen, to create for themselves an autonomous empyreological vocabulary. But insofar as this system of notions, without admitting ontological or philosophic concepts into its formal texture, and still more without any subordination to philosophy or borrowing of its principles, asks of the latter to furnish it, as its climate and conditions of existence, with those preconceptions of a general order, and that sense of its own significance in the universe of thought of which every science has need, and also those stimulations of a heuristic order, thanks to which it progresses in via inventionis, in the way of discovery. This system of notions, far from raising a sort of mechanistic pseudo-ontology, is, in a way, in dynamic continuity with the specifically different system of ontological notions of natural philosophy. Indeed, it can only build up its autonomy in a truly scientific way, escape the disorder, the arbitrariness, the conceptual wastage which dog the sciences of living nature, and experimental psychology in particular, on the supposition in the minds of those at work in it of a powerful philosophical discipline, at once logical and critical. It is for this reason that biologists today are beginning to realize that while giving an ever larger space to the physico-chemical and energetic analysis of living phenomena, biology can only rightly progress by expressly breaking with the mechanistic theory, the anti-mechanistic reaction in biology. Driesch's studies in Entwicklungsphysiology, developmental physiology, have from this point of view considerable historical importance. Following Driesch, under the influence it may be of Bergson, or of Schiller, or of the phenomenological school, or of Aristotelio-Thomist philosophy, biologists famous for their experimental researches have undertaken the enterprise of rehabilitating concepts such as those of the organic, life, immanent activity, even the soul, words which the science of last century felt a very virtue in avoiding and removing. They no longer fear philosophical conceptions, or August Krog and Remy Collins' insistence on the necessity of the work of the spirit in science, or to point out the accord between their conceptions and the thought of some philosopher, or even that of a poet of genius like Claudel. If Claudel, apropos of the auto-determination of living forms, speaks of notes which will play themselves in extending the fingers in all directions, Jakob von Uexküll, a key figure in biosemiotics, writes similarly, "Every organism is a melody which sings to itself." Frederick Buitendijk, a Dutch-German psychologist, opposes explanation and understanding, the analytic and mechanistic reduction, and the synthetic intellection of living things, material explanation and comprehension. And he vivifies his experimental researches by contact with certain ideas which rightly belong to natural philosophy, for example, the phenomenological intuition of the organic and conceptions, to which Claudel on the one hand and Bosman, Eric Becker and Vialatin on the other have come independently, of biological finality as going beyond strictly useful dispositions in virtue of an entitative superabundance and, as it were, ostentation. This reaction against the scientific conceptions admired by the 19th century is highly significant. It is perhaps the beginning of a veritable renewal, but it can only be efficacious and enduring if it maintains the essential distinction between objective fields, which cannot be confused without injury to the mind, and if a sort of prolific irrationalism, which only wishes to escape and to reduce every intellectual discipline, does not one day make us regret the inhuman stoicism of a soulless psychology and a lifeless biology, the purifications and macerations in whose name such sciences demanded of their initiates half of their intellectual and moral goods. The grand error of such science has been the desire to protect itself against the intelligence. In the endeavor to keep it out, it has risked dying of asphyxia. But the re-entry of the intelligence into science is an event which will not lack its dangers. It is obvious that this is a danger which the intelligence alone can avert. Only good philosophy can take the place of bad, but good philosophy, for all that, is a much more difficult task than its simulacra. At this point, we can observe the insufficiency of the phenomenological method as of Bergsonian irrationalism. Phenomenological intuition, unlike the Bergsonian, is of an intellectual order, but in basing itself from the outset on a form of reflective thought which rejects the thing, the transobjective subject, and as a result, applying itself to the pure description of the essence phenomenon, which, contrary to its nature, it isolates from extramental being, and so shutting itself up in a noetic atomism comparable to the Cartesian pluralism of simple natures, fragments of evidence, and refusing to recognize the primary value of transcendental being in which all our notions are resolved and founded on truths known as such. Phenomenological intuition sticks halfway, neither able to overcome an empiricism of the intelligible, which in being a priori remains nonetheless radical, nor to build up a veritable metaphysical ontology or philosophy of nature. In the lack of such apprehension and a rational resolution in the principles of a philosophical knowledge of being, this intuition can only find a use for the real in the phenomenological sciences. It is from the point of view of its effect on the practice of the scientist that it interests us here. And there, while recovering, in fact, an interest in the extramental thing, a realistic value, an efficacy which this does not have for the philosopher as such. It remains without any adequate control and exposed to all the dangers of the arbitrary, as does the metaphorical, analogical process which immediately rises from it and endlessly increases. Rich in invention, able to free and feed the intellect, a precious instrument of renewal and discovery, it is in via judicii, in the way of judgment, that this method is deficient, and no clear-cut distinction between the ontological and the empiriological natural philosophy and experimental science, being possible where there is a lack of an autonomous ontology, of a natural philosophy existing for itself, the phenomenological method in the act of delivering biology from the mechanistic tyranny, risks the introduction into it of concepts which are valid as such for natural philosophy, but valueless for science, and often also without value for the philosophy of nature. Finally, the very deliverance of which I have spoken runs the risk of being illusory, if, all empiriological knowledge having been given over into the hands of physico-chemical analysis, all rightly biological perception is found in fact turned over to natural philosophy invading the field of science, while this philosophy in its turn runs the risk of giving place to an intemperate vitalism, the counterfeit of an authentic ontology of the living, and that irrational metaphysic which once gave natural philosophy a fallacious renown. It is natural that the initiators who have won back the value of its objects for biology, like Driesch or Buitendijk, should be preoccupied with natural philosophy as well as their own science. We know that these preoccupations have finally led Driesch to devote himself to philosophy alone. But this union of two formalities in one thinking subject should not cause us to forget their distinction, a distinction which is fundamentally important, as much in the interests of philosophy as of those of science. This is why I have insisted on the existence, at least as theoretically requisite, of an autonomous experimental biology as distinct from the philosophy of the living organism. In other words, on the existence of an empiriological analysis, not only physico-chemical, but also rightly and irreducibly biological, of the world of living bodies, which should not be confounded with the ontological investigation proper to natural philosophy. This double empiriological analysis, at once physico-chemical and strictly biological, the former being subordinate to the latter, constituting experimental biology, as opposed to the philosophy of nature, in this case of living nature, with which it remains in continuity. The work of scientists like Heidenheim, Brackett, Queneau, Remy Collin, Hans Andre, and Émile Rode alike attest that an analysis which is at once rigorously empiriological and strictly biological has not only a possible existence. Specifically distinct from such an analysis, the ontological and philosophical knowledge of living things gives it its rational justification. In effect, it belongs to this latter to destroy the roots of the two illusions of mechanicism and vitalism, understanding this latter word, in the abusive sense which the history of medical and biological science obliges us to attach to it. In fact, classical medical vitalism is bound up with a conception of life, the counterpart of mechanicism, which on the one hand, from the philosophic point of view, has all the defects of dualism. The organism is there taken to be an already constituted corporeal substance existing as such, which is in addition inhabited by a strange principle, vital spirit or vital energy, and which on the other is repugnant to the rightful claims of scientific analysis, in the sense that it posits beside the physico-chemical means of life other principles of a specifically vital order which contradict physico-chemical laws and quarrel with them for possession. In such a conception, the vital has nothing in itself except what is abstracted from the physico-chemical, and it will thus be more and more reduced in the degree to which the physico-chemical study of phenomena progresses. The authentic conception of the organism is no less opposed to vitalism so understood than to mechanicism, the animist or hylomorphist conception, for which the principle of life is the formal principle itself. In the Aristotelian sense of the word, the substantial act or entelechy of the living body. so that the energetic and the psychic matter and soul make up one soul and same being, which exists with all its constituting determinations and structures, physico-chemical and vegetative, or sensitive or intellective, only by the soul. Thus, the vital is not juxtaposed, but rather superimposed on the physico-chemical, and a rightly biological experimental analysis is by so much more requisite in the degree to which the physico-chemical analysis of the phenomena of life advances. Concerning the true and the false philosophy of the progress of the sciences in modern times. It follows from these considerations that if natural philosophy receives the experimental sciences, as I pointed out above, like an empiriological body, it is in a different way in the case of sciences of the physical type, and in that of sciences of a biological one. In the first case, where the resolution of concepts is of an empiriometric order, it needs to separate insofar as is possible, in the results of such science, what is deductive explication from the mathematical forms by which these facts are established. In the latter, it can enter into continuity with the direct line of apprehension, whereas with the rational beings constructed by physico-mathematical theory, it can only know a secondary continuity in the line of images or myths. In the second case, where the resolution of concepts is of an empirico-schematic order, it can find a basis, interpreting them in its own proper light, in the results of experimental science in their integrity. In another way, I hold that a particularly important truth results from that critical analysis of the empyreology and ontology of the sensible to which this chapter has been devoted. It is that the more and more clear differentiation between knowledge of an ontological and of a physico-mathematical type is not simply a contingent fact due to particular historical circumstances, but one that corresponds to a necessary law of the growth of speculative thought, and in effect, constitutes one of the most authentic marks of the progress in the morphology of knowledge, which thought has accomplished in the course of modern times, and one of which both reflective and critical philosophy must take cognizance. It has been pointed out that the ancients, although they were clearly aware, in certain privileged fields, of the methods of scientiae media, middle knowledge, had nevertheless a tendency, in fact, to subject all knowledge of nature to the laws of ontology and philosophy. A similar and inverse error, all the more grave in that it does not arise from a flaw in the apprehension of fact, but from conscious theory, consists in only allowing as legitimate apprehension, at least in the knowledge of nature, empyreological knowledge dressed up in some other name. This was the error of the positivists, who gave over to it, if the phrase may be allowed, the whole extension of the universe of thought. It has been committed again, though in a new fashion, and this time in the very name of metaphysics, by those philosophers who in the knowledge of nature keep only empiriometric explanations and holding the sciences of life as worth nothing, wish to find in mathematical and physico-mathematical knowledge the unique type of all rational activity, when not purely reflective, worthy of the name. It is impossible to avoid applying the tide retrograde, and indeed pre-Copernican, to the attitude of these philosophers. The arbitrary command of a metaphysic, which constitutes itself by a sweet and total renunciation of being, and the object obliges them to return to the positions of the most naive epistemological monism, proclaim this time for the benefit of that form of knowledge which is at the farthest remove from the grasp of the real in itself. This fake philosophy of scientific progress thus interdicts itself from discerning the profound meaning of the Copernican evolution. It misunderstands the admirable organic diversity in the play of the intellect manifested either in the heart of science itself, or in the distinction drawn between science and philosophy by 4 centuries of scientific development. All that remains of the reason in such philosophy is reduced to the employment of mathematics, and what I have called here the empiriometric use of the intelligence. This is, if I may put it so, a rationalism which has retired from active business, and which is endeavoring to carry on life as a rentier, which can in fact only draw its subsistence from the reflective supplies of the works of the ancient reason. But what I have wished to point out is that the principles of a realist noetic, as they have been exhibited in this book, give space in their system of knowledge for the rightful methods and just appreciations of the reason of this nominalist rationalism, and recognize their value within certain defined limits, while at the same time marking their insufficiency as making up the being of all thought. Perhaps there is an indication of the truth of a doctrine of integral power in the positive elements which are found in systems invoking other principles. In any case, it seems that a true philosophy of the progress of the physical and mathematical sciences during the modern period, precisely because it appertains to it to disengage by critical reflection the spiritual values with which they are pregnant, must necessarily recognize in this progress a sign not of its reduction and diminution, but of its completion and a growth in the organic structure and differentiation of thought. It must also show on the one hand the incompatibility between this mathematic and empiriometric progress and knowledge of the ontological type, which is proper to philosophy, and on the other, a respect for the nature of those experimental sciences which escape by their substance a complete mathematization, and do justice to their methods of work, which, in the degree to which they further affirm their autonomy, cover a widening range of the scientific field. In effect, it would be completely arbitrary to refuse the rank of authentic forms of apprehension, meriting the attention of the philosopher to biology and the other sciences of the same epistemological type, which contribute more and more importantly, and perhaps one day preponderantly, to the progress of speculative thought.